There's lots of data now showing that people that are doing these like short bursts at least a minute long, but up to 3 minutes, they're moving faster with intent, and it's having outsized effects on health outcomes. So for example, individuals that do on the high end, so they're doing 3 minutes of this short burst of an unstructured type of exercise snack, and they do it 3 times a day. So it's a total of 9 minutes a day. Okay, that's associated with a 40% reduction in all-cause mortality, 40% reduction in cancer-related mortality, a 50% reduction in cardiovascular-related mortality.
Wow.
9 minutes a day.
Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. My guest today is Dr. Rhonda Patrick, a biomedical scientist and leading public health educator. For over a decade, Rhonda has been one of the most trusted voices in building science-based health protocols. Today, we discuss what the latest and best research says we should all be doing to improve our health and vitality and avoid disease. Rhonda shares with us her exact exercise, nutrition, supplementation, and sauna protocols, and we get really detailed about the mechanisms and logic behind each one. We also discuss the things that science say you can do to significantly reduce your cancer and cardiovascular risk, including how to reduce visceral fat and arterial plaque. Today's discussion truly leaves no stone unturned. We discuss how eating can increase inflammation, believe it or not, ways to support your gut health, creatine, vitamin D, why broad vitamin and mineral and fiber support is crucial, as well as the different forms of magnesium and each of their unique effects. We also discuss omega-3s and why prescription sources of omega-3s may be the cleanest and most cost-efficient way to obtain sufficient omega-3 intake. We also discuss the importance of prioritizing regular resistance training and HIIT workouts over protein. You still need protein, but emphasizing the exercise component is crucial. And we discuss fiber, micronutrients, and why short-term fasting can be beneficial. Dr. Rhonda Patrick is a true wealth of knowledge, and today she generously provides us a masterclass on how you can design and adjust the exact health protocols to meet your specific needs. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. In keeping with that theme, today's episode does include sponsors. And now for my discussion with Dr. Rhonda Patrick. Welcome back, Dr. Rhonda Patrick.
Excited to be here.
It's been a while. I'm so excited. There's so much to go into. And I'll start off the same way I started last time because it's even more true. Thank you for being first person into this public science health education business. I don't know if everyone's aware of it, but you were the first person in, which is why I didn't say first man in, because the first person in was and is a woman, and you've done a marvelous job of educating people on science, how to parse papers and data, health practices, and the rest of us are just trying to follow in your wake. So thank you very much. I just want to thank you for being first.
Oh man, thank you so much for that. And also thank you for doing what you do. I mean, you really do a great service for science communication, education, helping people love science and get healthier.
Oh, thank you. Well, you're the pioneer. It's not always easy being a pioneer, but we all benefit. So let's jump in at exercise because lately, you've actually been posting your workouts, which is awesome. And you're clearly very fit. I learned before talking to you today that you were a competitive athlete. You were a long jumper or triple jumper?
I was a long jumper, but I would say my real competitive athleteness comes from my jump roping.
Okay.
I was on a professional jump roping team.
Professional?
Yes.
Okay.
Yeah. It was, we would compete. So my friend and I started the team when we were in second grade, and it was called the San Diego Sandskippers. It was part of the International Rope Skipping Organization, which was actually started by her uncle. But there's jump rope teams all around the world. And, now I think there's a new name, but like it got taken over by the Universal Jump Rope Team or something like that. I don't know exactly what it is. But so I was on a team, and every year we would compete in Boulder, Colorado. There's competitions for all kinds of, jumping rope. And I would perform and start jump rope teams around different schools in San Diego. So I used to get out of school, get out of school free card, and my partner and I would go and start do workshops at other schools and help them start jump rope teams. And the idea was cardiovascular health, healthy heart, and So that's really, I would say, my roots with being a competitive athlete.
Awesome. I love skipping rope. Is it okay to say skipping rope or is jumping rope the okay?
Skipping rope, jumping rope.
And actually, it's a great opportunity for me to ask you what your thoughts are about exercise that isn't just linear, right? I know like real jump ropers can do crossovers, and these days I'm seeing a lot more about rope flow. I think it's David Weck and others online, or stuff that's getting people out of the standard curls, bench presses, lunges, and getting movements that are more, just for lack of a better term, across the body. Do you think there's something to that in terms of real physical benefits? I mean, I imagine there is.
Sure. I mean, I wouldn't be the expert to be able to give you a good answer on that, but I do think that jumping rope in general has unique benefits. In addition to, obviously, it's a great cardiovascular exercise. You're getting the weight-bearing aspects as well for building bone density. And I think that earlier for me, I was doing it as a young girl. So important, right? Because you're kind of banking that bone density early on, which is important because at some point, menopause will hit and estrogen goes down, and so you start to lose more bone. But I'm sure there's a lot of benefits to jumping rope beyond what I'm describing as cardiovascular benefits and bone benefits that someone else could answer.
Well, I'm certainly going to get back to jumping rope now that we resurrected it in this conversation. And I have to say, bone density measurements aside, you have awesome posture. I notice people's posture.
Oh, really?
Yeah, I didn't mean to put you on the spot here, but yeah, when I walked in, I was like, if you ever interacted with Rhonda in person, which I have, you have amazing posture. And these days, good posture is rare. So who knows, maybe the things are related. I imagine they probably are, bone health and posture and so forth. In terms of the sorts of exercise that people are more familiar with, what's your routine look like? And what sorts of things in your routine are non-negotiables? And where's the place for experimentation and kind of what you're exploring now?
So for me, exercise is part of my personal hygiene, as you and I were discussing. It really is a non-negotiable. I absolutely have to do exercise, just like I have to brush my teeth. And, I kind of got that from Dr. Ben Levine, who's probably one of the world-leading cardiovascular exercise physiologists. He's at UT Southwest in Dallas. Just want to shout out his name because I've really learned a lot from him. But the non-negotiables for me really are getting cardiovascular exercise and getting my resistance training. So building muscle, maintaining muscle strength as well. So my routine for me, I work out probably about 5 to 6 hours a week. And those workouts, I largely am doing a combination of high-intensity interval training that's not necessarily like the Norwegian 4x4, where I'm going as hard as I can for 1 minute or 4 minutes and then recovering for 3 minutes and doing that 4 times. It's really, the Norwegian 4x4 is a hard workout. It's really good for improving your cardiorespiratory fitness, which I think is one of the best markers for longevity. We can talk about that. I do a lot of, it's a mixture of doing, rowing machine, getting on the assault bike, and then mixing it in with lifting weights, doing some deadlifts, doing squats. So it's really, for me, non-negotiable to do my vigorous intensity exercise is what I would call it. So you're really kind of getting your heart rate up to, 80% max heart rate at points, not always, but especially during the intervals. I would say that's a non-negotiable for me.
How many days a week are you doing that?
I do my longer HIIT workouts. So I have 4 days a week where I'm doing at least an hour. So two of those sessions are more of a CrossFit type of training, where I'll do the first 30 minutes will be strength training. So I'll just be lifting heavier with fewer reps.
What's the rest between sets? Sorry to get granular, but people will wonder.
What's funny is I typically rest about 2 minutes between my sets. I recover pretty quick. And I do it with a coach, and my coach usually tells me that I'm spot on. I'm like ready to go, and it's been about 2 minutes. So I usually, that's my recovery time. And so the first 30 minutes is strength training, and that'll be like deadlifts. It'll be, squats. I'll be cleaning. I'll be doing front squats. Sometimes I do barbell or back squats, right? Like it's a mixture of different types of strength training. And then the last 30 minutes is more of a high intensity interval training session. So it'll be like, where I'm getting my heart rate up. So I'm mixing in the row machine, and then I have maybe I'm doing cleans, but they're lighter, right? So it's like more reps, but lighter load, right? So that's I do that twice a week, and that each is an hour session. And then I do also twice a week about an hour and 20 minutes of, it's also more high intensity, but I have more recovery time because I'm doing it with my girlfriends and we kind of chit chat a little bit. And so, but it's a very similar. We do, rowing machine, assault bikes. We do the skier, Rogue has that skier. And then we mix it in with, chest presses, and we do, assisted pull-ups, and we do, lighter squats with like larger, more reps. So that's another, 2 hours a week. So I have 4 hours a week of just doing a lot of that sort of CrossFit, HIIT type of training. And then I mix that in with my more like runs that I do, which I would say are they're still considered vigorous intensity. They're just not quite as high intensity. And I run in like maybe 6 miles a week. So maybe at my max. But these days I'm mostly running probably 4 miles a week. So those runs tend to be like, sometimes they're 2 miles, sometimes they're 3 miles. And
do you enjoy running?
I do. I do. And I think it's important as well. And sometimes I'll run with my husband and we just kind of like chill out and talk. And, it's a nice time for me as well, just to kind of do that with him. And then on weekends, I'll probably do like a hike with my family. And sometimes we'll do like a sprint up the hill and, but it's more just enjoyable time in nature. Still moving, but it's kind of family time too.
Weight vests on the run or hike?
No, I don't. I'm kind of wanting to experiment with that, but not really. I'm just kind of, sometimes we bring our puppy and, so it's more about the experience, I think, than like, I get a lot of workout throughout the week.
Sure.
But it's like you said, it's non-negotiable for me. And times when I'm like today, so I had a long drive, and so I got on my Peloton and I did a 10-minute. I did a 10-minute Tabata back-to-back. So it was like 2 back-to-back Tabatas, right? So it ended up being 10 minutes. So it was like 30-second recovery in between the 2 Tabata sessions, 2-to-1 ratio, 20 seconds on, 10 seconds off. But like I have to do something every day. And if I'm traveling or I have like an early podcast or something, I'll just jump on the bike and I have to get that blood flow. Sometimes I'm in my hotel room and I don't want to go to the gym. I don't have time. And I just, in my room, I do the air squats, I'll do high knees, jumping jacks, and I repeat for 10 minutes. I'm getting my heart rate up and I'm, I've got sweat on my brow. Like it's not like the most intense workout, but it's so important for me. There's a variety of brain benefits that have been shown with even just 10 minutes of this vigorous type of intensity of workout you do, where you probably have seen this data where it's like just 10 minutes of this vigorous type of exercise, you're immediately increasing neuronal connections. There's been studies showing that you have an improvement in executive function by like 14%, which is pretty big. I think it was like a 50 millisecond improvement processing speed or something, which doesn't sound a lot, but actually it translates to a big improvement in executive function. So my brain works better. I feel better, better mood. There's even studies that have compared impulse control after various types of intensity of workout. So like there's one study that compared a more low intensity versus moderate intensity versus high intensity. So you're talking about like walking versus maybe jogging slowly where you can still have a conversation versus like you're doing a HIIT workout, right? When you're on, you're not really talking because you're going as hard as you can during that interval. And it was the high intensity, vigorous intensity exercise that really increased plasma serotonin, which has been shown to associate with brain serotonin. Those studies have been done. And serotonin is very important for, as you know, for impulse control. A lot of people think about serotonin with respect to mood because we have these selective serotonin reuptake inhibitors, SSRIs, that are used to treat, depression, major depressive disorder. But serotonin, as you know, does so much more than that. And impulse control is one of the big things that serotonin plays a role in. And so those studies showed that plasma serotonin increased in the higher intensity group, and that correlated with improved impulse control. So, of course, for us now in the modern day society that we live in, we're constantly being bombarded with, social media and all these things. And like, you have to be able to kind of like filter that out and not like just go with the impulse, like check my social media, check my, and how many likes did I get or whatever. You need to just be able to focus. And so that, for me, serotonin is important. And so I like to get that vigorous intensity exercise as well.
I'd like to take a quick break and acknowledge our sponsor, our place. Surprisingly, toxic compounds such as PFASs, or forever chemicals, are still found in 80% of nonstick pans, as well as utensils, appliances, and countless other kitchen products. As I've discussed before on this podcast, these PFASs, or forever chemicals like Teflon, have been linked to major health issues such as hormone disruption, gut microbiome disruption, fertility issues, and many other health problems. So it's very important to avoid them. This is why I'm a huge fan of Our Place. Our Place products are made with the highest quality materials and are all PFAS and toxin-free. I particularly love their Titanium Always Pan Pro. It's the first nonstick pan made with zero chemicals and zero coating. Instead, it uses pure titanium. That means it has no harmful forever chemicals, and it does not degrade or lose its nonstick effect over time. It's also beautiful to look at. I cook my eggs in my Titanium Always Pan Pro almost every morning. The design allows for the eggs to cook perfectly without sticking to the pan. Right now, Our Place is having their biggest sale of the season. You can save up to 40% site-wide now through April 12th. Just head to FromOurPlace.com/Huberman. Again, that's FromOurPlace.com/Huberman to save up to 40%. Today's episode is also brought to us by Lingo. One of the most important factors in your short and long-term health is your body's ability to manage glucose over time. Glucose directly impacts our brain function, mood, and energy. You want your glucose relatively stable across the day without big peaks or valleys. This is why I use the continuous glucose monitoring app from Lingo by Abbott. Lingo provides minute-by-minute glucose data directly within the app, showing you how your glucose responds to food, exercise, and stress. This information can help you make smarter choices to support your health both now and in the long term. The CDC estimates that more than 1 in 3 American adults has prediabetes, and that many of these people don't know they are living with prediabetes. Visibility about how your diet and activity affect your glucose can be the first step toward informed conversations with your doctor and making smarter daily choices. If you'd like to try Lingo, Lingo is offering Huberman Lab listeners in the US and UK 10% off a 4-week plan. Just visit hellolingo.com/Huberman for more information. Terms and conditions apply. Again, that's hellolingo.com/Huberman.
I love that you mentioned other functions of serotonin because, as you point out, it is so heavily associated with this mood aspect and certainly has a role there. But the impulse control piece is, I think, is a non-trivial aspect to the effects of exercise and just generally. I'm curious, do you bring your phone or feel compelled to check your phone during workouts? Or are you able to just say, I'm compartmentalizing now, this is the workout, you might put on music or maybe text here or there if you need to, but are you able to compartmentalize, or do you struggle with the phone during workouts?
Oh, I don't bring my phone to my workout at all. Like, I don't. Now, I do have a watch that I wear that, if there's like an emergency, I'll get a text message. Oftentimes I put it on silent, on no notifications because I don't want to be bothered. But I don't really check my phone. I don't really like checking things like social media. For me, it's just a distraction. And frankly, I think it's terrible for people's brains, even though my business kind of depends on it somewhat. I think social media is not really good for people, to be honest. So I don't really check my phone or bring my phone to my workouts. My workouts are, I like to chat with my friends when I'm working out with them, and that's fun. Yeah.
That's in real life.
Yes.
IRL, as the kids say.
Yeah. That's in real life. And phones for me are not something that I bring to my workout.
Great. Yeah, I've been experimenting with not allowing the phone in my gym, and just the workouts go so much better. And I find that the mental and physical resetting aspect of working out just seems to be enhanced. But sounds like you were already there and I'm just arriving. So I have a couple other specific questions about your workouts because for my own interest, and I know many people will wonder, for the dedicated weight workouts, are these whole body workouts? And you said low reps. Maybe you could just tell us what low reps is for you. And then seems like the ever-present question is to failure, close to failure. I mean, just to round out that portion of the workout picture. The
workouts that I'm doing with my strength training workouts with my coach, it really depends. Most of those workouts they're multi-joint workouts. So I am most of the time doing, some either front squat, back squat, or I'm cleaning it as well, right? Which obviously the weight goes down if I'm cleaning it because it's hard to clean. It's also it's the thing that I hate doing the most.
Cleans.
Oh yeah, cleans with front squat because it's really hard. And for me, I mean, for others who've been doing it for years, I'm sure it's like, they love it. But for me, it's very hard. I've only been doing clean since, February 2024. So I'm pretty new to it. And so it's mentally like I have to overcome that challenge, which, by the way, once I started doing all this sort of weight training, I've always been an endurance junkie. I used to like to go long runs and, races and stuff like that. So for me, that's like my safe spot, right? That's what comes easy to me. Weight training and resistance training, strength training, definitely not something that I've done my whole life. I'm so glad that I started doing it, but very, very challenging for me. And so I would say the biggest effect was on my brain and the ability to handle stress better, where it was like unbelievable because it was so hard. And I just didn't want to do these cleans, and these front squats. And then the rest of my day was not as hard. And that, to me, was like the biggest surprise for this type of training. But anyway, so I do a variety of, if I'm going heavier, then it, depends. Sometimes I'll start off, it's like, okay, we do 5 reps. And then we go down to 4, and then we go down to 3, and then we go down to 1.
Oh,
right?
You're doing singles.
We do. Mm-hmm. I know. Yeah.
Awesome.
And that's the hardest. It's the hardest. But then there's like my coach will like, it's just one. It's just one. Sometimes we'll do like 6, 5, and then we do 4 twice, and then we do 3 twice, right? And so it all depends, also on the day. There's some days where I'm just like, can we do lower reps and like lighter weight, right? Where I'm just like, this is the day for me. I'm stressed. I'm not here. Like, so you kind of have to modify your workout, right, according to how you feel that day. But I would say that the majority of my strength training workouts are deadlifting. I love deadlifting. I think I'm pretty good at pulling that weight up, lifting that weight up.
It's a straight bar, hex bar.
I do a straight bar.
Mixed grip. There's so many variables.
Straight bar,
Yeah.
and it's the same deal with that. Like most of the time with strength training, we'll do, we start off at like 5 or 6 and then work our way down. And then I usually do a drop set after, any of those sessions where I'll do 10 and then it's like a lot lighter, right? So those are typically my strength training sessions or multi-joint. Sometimes I'll do accessory sessions, where I'm working, I do, the dips or the Bulgarian split squats. I mean, just the accessory stuff that you're working, the like smaller stabilization muscles and stuff like that.
I love that you call Bulgarian split squats accessory smaller muscles. For a lot of people, that's the compound work, which is just, I have to say, I am inside, I'm just like so delighted because, I mean, obviously weight training is something that's caught on broadly for men and women now, but I don't know many women, and I know they're out there, but I don't know many women who are working down to singles on multi-joint, like real multi-joint, like, deadlifts, cleans. I know they're out there, but it's not that common to see in gyms. And this is going to no doubt spark a debate because, some of the older, slightly ornery, but very credentialed strength training folks have been online recently saying that as people past 35, that they shouldn't do squats, that they shouldn't do deadlifts, and certainly shouldn't do them heavy because of this whole thing of, you can do higher reps and go to failure and still get hypertrophy. But what I love is that you're not necessarily talking about hypertrophy, maybe some hypertrophy, but this is about strength. This is about building more strength. And triples and doubles and singles, that's awesome.
It's hard.
That's awesome.
It's so hard. And it's the part that I'm like all about, like the last 30 minutes when it's hit, and that's hard. It's a different kind of hard. But for me, the strength training is the hardest, and there's definitely a mental component, right, where I do not want to do it. It's like you talk about with cold plunging, right? Like you just, it's so unpleasant, and you don't want to do it, and like you do it, and it's like that mental toughness that you're building, right? That's what I experience when I'm doing these, strength training exercises that I'm doing, and I don't know if it's going to get easier. Maybe it will. It hasn't yet. I still dread it, but I do it, and I'm proud of myself for doing it. But it's definitely hard, and I am getting stronger, I think mentally and obviously physically as well. But I have to add in the aerobic as well, though. I think that's really important.
That's your base. Yeah.
Yeah.
Sure. You love it.
I love it, and I do think cardiorespiratory fitness is very important.
Sure.
For long-term health, as well as obviously building muscle and strength.
Well, on the one hand, I want for you as a friend for you to hate the heavy work less. On the other hand, I don't, because of this literature. I'm sure you're familiar with it, but the anterior mid-cingulate cortex, this brain area that is hyperplastic throughout the lifespan, which is rare for a brain area. And it enlarges when we do things we don't want to do. I mean, it's so clear. It's not just about doing hard things. It's about doing the hard thing you hate. And for you, that sounds like the heavy compound movements. For me, yeah, I don't like the cold plunge, which is why I do it. I don't think it's magic. I just think it's a surefire stimulus that I hate to get mentally stronger. And I think having something that you really despise, that you know is good for you, seems to keep this anterior mid-cingulate cortex volume either increasing or the same. And that's actually the thing in these so-called superagers that is the strongest anatomical correlate that we have. So on the one hand, I hope it gets easier. On the other hand, for your sake, I hope it doesn't get easier, because it's going to be so much more beneficial.
I have a coach who can tell when it's getting easier, and she will definitely up the weight. I mean, it keeps going up. And so it doesn't, it gets easier in a sense, but it doesn't, right? So, I mean, I think that's the whole point, is you're building strength and you keep making it heavier, and it becomes harder again because now it's heavier.
Awesome.
But, and I haven't gotten injured. So that's also, knock on wood.
Yeah, no, knock on wood. Thank you for rounding out that picture. It's super inspiring for men and women, so.
It's not easy to post on social media because obviously I'm a newbie. So I have all sorts of, things ways I can improve. But I'm posting it,
Well, and the fact that you're working down into triples, doubles, and singles, I think is something that I'm trying to do more of. And I think this notion that you can get hypertrophy with higher reps if you take it to failure. Sure, I totally agree, read the studies, totally agree with the data, but not everything is about hypertrophy. I think that's what people forget. It's not all about growing muscle. NVO2 max, which is great, but it's not all about the top contour. And what I love about the way you approach everything is you go through multiple layers of the health stratus, as it were. This is probably a good opportunity to talk about protein, because I have a very specific question about protein. We all hear 1 gram of quality protein per pound of body weight or lean body weight. That's sort of what's thrown at us. By doing the heavier weight training, do you notice that your protein appetite has increased? Like appetite specifically for protein foods?
I don't know that I have. I interestingly have been doing a little bit more intermittent fasting, in which, people think about intermittent fasting, they think about it as just one thing, one intervention. I think it's two. There's a behavioral aspect to it where it's a tool to sort of lower the amount of calories you're taking in. The other one would be this metabolic switch. But so I've actually, since, September, maybe, last September of 2025, been doing more intermittent fasting. And what I mean by that is just eating less. And the reason for that is because I noticed that everything that I was doing, which was, I eat healthy, I exercise a lot, and yet I was sort of gaining more fat in the belly section, right, the visceral fat. And the only thing that really helped me stop that, put the brakes on, was getting more in a caloric deficit. So maybe my drive to do that kind of is skewing whether or not my appetite for protein would go up. But I personally am on the scale of 1.2 to 1.6 grams per kilogram body weight.
Per kilogram, okay.
Per kilogram, which is probably a little bit less than the pound.
It's a kind of a throwaway statement, a gram
per pound
of quality protein as defined as something with, lots of the essential amino acids and so forth, per pound or per lean pound of body mass. Which is something I think I and many other people shoot for, but I'm curious how religious you are about the, getting a certain protein amount or per meal.
Basically, it wasn't working for me in terms of I was really trying to aim for the higher end of for me, 1.6 grams per kilogram body weight, or even a little bit above that. And what I found, what was happening is that I was actually gaining more weight because I think I was consuming more calories at the same time. If you're getting it from whole foods, right? That's just kind of naturally going to happen. And so I had to slide down. But I'm still, like I said, I'm still getting within that range of probably on average, maybe 1.3, 1.4 grams per kilogram body weight. And it's really worked well for me. But like, people are different and you have different goals, right? You know, like I'm gaining muscle mass and I feel like all my training is like the most important thing. And I think that generally speaking, I think people should become more obsessed with training and less obsessed with protein. Like the protein will complement the training. And as you mentioned, if you're training, perhaps your appetite for protein will increase. And so you'll start to eat, more protein and less refined carbohydrates. I already wasn't eating a lot of refined ultra-processed foods in the first place. Probably not the answer you were expecting, but it's really, for me, like I just, focusing on getting more protein was not working for my body. In terms of, but then again, I'm 47 years old, that perimenopause phase, very different than someone who's 37, maybe.
I don't know the answer to that. I do know that I hear from more and more people these days that they are having a hard time getting that 1 gram of protein per pound of body weight. It feels like a lot to them is what they're saying. They feel like they're kind of forcing themselves to do it.
You shouldn't feel that way.
Exactly. So I'm actually really pleased with your answer, not because I have an agenda here, but because I and many other people seem to feel like unless there's a lot of resistance training or tremendous demands, like hiking, while backpacking, where you burn tons of calories, you're basically rucking like 9 hours a day, right?
Right.
That they have a hard time getting that much protein down. And I think that's also the case if people are eating starches, like I eat rice and oatmeal and some breads and things like that. Not a lot of bread, but it sounds like you eat starches.
I do eat oatmeal too. It does satiate you. These days, because I really kind of more focused a little bit on, I did want to calorically restrict somewhat without, being unhealthy. Obviously, you can take every stressor to a bad, unhealthy place, right? You don't want to starve yourself. You don't want to like not eat enough food. But my meals are mostly like healthy proteins. So I have homemade turkey burgers. I eat a lot of those, and then I eat chicken. I pasture raised chicken. I do still eat wild Alaskan salmon, and then I'll also mix in some like filet mignon. Like I like grass-fed steak as well.
Yum.
Those are my protein sources, and always I pair it with greens. So or like some sort of vegetable. Most of the times it's greens because they're the most micronutrient dense. And so these days I'm eating a lot of sautéed collard greens that are like pre-prepared, has garlic and onion, and I'll put that, I'll have that with my meal, or I'll have some, sautéed kale. Sometimes I'll have a salad with it, but the portions are smaller. And like I said, I also do a little bit of intermittent fasting. We can talk about that as well. But that's kind of these days what I'm doing for my meals. I haven't eaten as much. Sometimes I'll eat the high protein oats. They have those high protein oats. That have you seen those? They're pretty good.
I eat oatmeal, but I like protein foods. I like vegetables. I like fruit. I feel very lucky to like those foods mainly.
Yeah.
And then the starch for me has to be very clean. I like oatmeal, rice, homemade pastas I'll eat. Like if I go out, sometimes I'll have some homemade pasta or a sourdough bread or something. But I find that most starches that are out there in the world have a bunch of other junk in them, and I just feel lousy. Get kind of sleepy afterwards. So it sounds like we eat pretty similarly, although I probably eat more starches than you do.
It's the more processed types of carbohydrates that, as you mentioned, it's like typically you don't feel good after you eat them. And, part of that's the postprandial inflammatory response, because some of those foods are a little more inflammatory. I mean, a lot of additives and stuff that are affecting the gut permeabilization. You're leaking lipopolysaccharide into the bloodstream, right?
Yikes.
That's activating the immune system.
We used to inject, I don't do any animal experiments anymore, and I'm actually grateful to not do them. So I didn't like working on animals, but it was what we did until I decided to work on humans. But we used to inject LPS to stimulate an inflammatory response, to kind of prime a regeneration response that you could get through macrophages and things like that. And so LPS is a very potent way to generate local or even systemic inflammation. I think hearing that some starches will stimulate LPS, that's interesting.
Well,
and
let me clarify.
Squares with my experience.
Let me clarify.
I'm not challenging. No. I'm not challenging. It squares with my experiences. I'm one of these, I never get stomach aches, I never get headaches. If I do, something's badly wrong with my stomach or my head. But if I eat certain starches, I'll be like, I feel lousy. And I'm wondering if it's this.
So we have about a gram of LPS in our gut, like that's on average, because lipopolysaccharide is the outer component of a cell membrane of gram-negative bacteria, right?
Yeast. Yeah.
We have a lot of bacteria in our gut, gram-negative bacteria, right? Trillions of bacteria in our gut. So when we eat food, typically, like our gut epithelial cells, we have a tight junction that's holding them together. When we eat food, they transiently open and then close. Like it's kind of a normal response, right? I would say the opposite end of the spectrum of that would be like celiac, where they eat gluten or something. It opens up and stays open, and so you get like a ton of LPS leakage into the system, which causes massive inflammation. It just happens with meals in general. You do get somewhat of a LPS response from a meal. Now, the type of meal does matter. So when I say refined carbohydrates, it's not necessarily like healthy, carbohydrates like vegetables. It's like you're eating something that is refined sugar, typically with saturated fat. So those types of foods really cause like LPS response. It's inflammation. It's bad. It's hard on the gut. But the postprandial inflammatory response essentially is that LPS getting into the system, activating the immune system, which draws the energy. I mean, it's very energy consuming to activate your immune system, right? That's why when you're sick, you're so sleepy too, right? Well, there's also cytokines that are somnogenic and promoting sleep, but like activating your immune system requires a ton of energy. And so when you're constantly activating the immune system, that's an energy sink, right? And so you do feel tired. And that's why a lot of times after a meal, you're feeling kind of lethargic.
Do protein foods of the sort that you listed off before, do they cause less opening of the tight junctions of the gut?
I think the big deal with the opening of the tight junctions in the gut is, eating a big meal will do it. Eating a very like ultra-processed food meal will do it. Interestingly enough, just eating a bunch of saturated fat without a fiber matrix, so like butter, you're just like eating butter. Don't ever do that. But like if you just eat butter, that's been shown.
My niece, when she was little, now she's all grown up, but when she was little, I taught her how to eat like a little bit of Kerrygold butter, and she loved it. So then we would do this thing where we'd do that. We won't do that anymore.
I mean, a little bit's fine, but like,
So
there's studies showing that it does, like saturated fat is hard on the gut.
Yeah.
Like I said, it's a sliding scale. Like meals in general do it, but it's like it's like you would think. The healthier foods that you're eating, like whole foods, you're getting less of that LPS response. And then of course there's gluten, and that complicates the whole story, especially for people that are celiac, right? Because
which is a small percentage of people are actually celiac,
Yeah.
right? But a lot of people seem to believe, and I believe them, that when they eat gluten, they feel worse than when they don't eat gluten.
I'm sure there's some people that are sensitive to gluten that do feel worse. And then I'm sure some of that's the nocebo effect, right? That's been shown with gluten in particular. Have you seen that study? Where people, there were people that think they're, gluten sensitive. And so they were enrolled in this study. And these individuals were separated into two groups. One group was given the bread with gluten, and the other group was given the bread without gluten. And the people that were given the bread without gluten had a terrible, abdominal, like they were bloated, they felt terrible. I mean, it was all, and there was no gluten in the actual bread, but they thought there was. So it was thought that there's a nocebo effect, where it's like the opposite of a placebo effect, where you've got that phenotype where you think things negative are going to happen, and you can make them happen. You can change your immune system, you can change your brain signaling, and so probably a combination of both with that regard. In addition to like the lethargy, so I was talking about in the context. That's why it sparked my interest. Is like you were talking about feeling tired after a meal, and I do think that is part of that reason for feeling sleepy, but. What's interesting about LPS, you talked about injecting it to mice, and I've also done experiments injecting LPS into mice. There have been studies where people have been injected with an amount of LPS that is, similar to what you would find your gut releasing into your bloodstream, or a placebo control, which in this case was saline. And individuals that were injected with the LPS, high amounts of inflammatory markers like TNF-alpha, I mean, we're talking like up to a 50% increase. Whoa. Over baseline, right? So high amounts of inflammation, which makes sense. LPS is activating the your immune system is like, there's a foreign invader, right? It's not a foreign invader. It's just the food you ate that caused transient gut permeability. And those individuals also feel depressive symptoms and feelings of like social withdrawal. So the inflammation is affecting the brain, right? These inflammatory factors are getting in the brain, crossing the blood-brain barrier, and affecting the way we feel. And we know now that inflammation plays a big role in major depressive disorder and depression. And not in all cases, but there's a subset, right, where it's really like it seems to play a big role. In fact, interestingly, there's been some studies showing that people that don't respond to SSRIs have very high amounts of C-reactive protein. So this was the biomarker for a classical biomarker for inflammation. I would argue it's not that sensitive, but nonetheless, it is a biomarker for inflammation. And so people that don't respond to SSRIs have high amounts of inflammation, which kind of raises this question of, is there like this subset of depression that's really inflammatory driven, right? Interesting. So the LPS is affecting not only our energy levels, but also our mood. And then, there's also evidence that, so we know that LPS binds to LDL particles through lipid-lipid interactions. And in fact, it's kind of part of the adaptive response. It's why you don't want to ever go get your cholesterol measured right after you're sick or had a very stressful event, something that causes inflammation, because you will increase VLDL production increases and LDL production increases. And it's sort of an adaptive response to bind that LPS to prevent it from causing more damage. And so it actually binds to LDL particles on the ApoB protein. So ApoB is a protein that is on these lipoproteins, and it's a very important protein because that is what's used by the LDL receptors present on our liver to recycle LDL particles. And so what happens is these LPS particles are now bound to our lipoproteins, and our lipoproteins are still doing their function, right? They're going around and they're giving triglycerides and fatty acids and to some degree cholesterol to our cells that need it, right? We're constantly making new cells and repairing, and our cells need that. As they donate triglycerides and fatty acids, they get smaller in size. The lipoproteins, you probably heard of small, dense LDL, right? Like that's a very dangerous type of LDL particle. And that's one that's kind of been donating along, getting rid of triglycerides and whatever. If you think about a train with cargo, it's donating, dropping off the cargo. And so when it's time to get recycled back into the liver, what do you know? The ApoB protein's obscured by that LPS, and it's not recycled. And so it gets lodged into the arterial wall. And because there's an LPS bound to this, small, dense LDL particle, macrophages, which are, as you mentioned, it's like the first line of defense against something like a bacterial invader, right? It comes and chews it up, right? Gets rid of the problem. So macrophages come in because they're seeing this signal of LPS and think it's a foreign invader when it's actually just a small, dense LDL particle bound to LPS that came from the gut, tries to engulf it, but it can't because it's not bacteria. And you get the macrophage stuck to that lipoprotein LPS, complex, and you get the formation of a foam cell. You probably heard of a foam cell. It's the beginning of atherosclerosis. And so this is where gut health and the food we eat is it's linked to cardiovascular health, right? Gut permeability, getting that LPS into our circulation is actually not a very good thing because you're basically slow dripping in that inflammation, that inflammatory signal, and it's wreaking havoc in our arteries, on our brain.
As many of you know, I've been taking AG1 for nearly 15 years now. I discovered it way back in 2012, long before I ever had a podcast, and I've been taking it every day since. The reason I started taking it, and the reason I still take it, is because AG1 is, to my knowledge, the highest quality and most comprehensive of the foundational nutritional supplements on the market. It combines vitamins, minerals, prebiotics, probiotics, and adaptogens into a single scoop that's easy to drink, and it tastes great. It's designed to support things like gut health, immune health, and overall energy, and it does so by helping to fill any gaps you might have in your daily nutrition. Now, of course, everyone should strive to eat nutritious whole foods. I certainly do that every day. But I'm often asked if you could take just one supplement, what would that supplement be? And my answer is always AG1, because it has just been oh so critical to supporting all aspects of my physical health, mental health, and performance. I know this from my own experience with AG1, and I continually hear this from other people who use AG1 daily. If you would like to try AG1, you can go to drinkag1.com/Huberman to get a special offer. For a limited time, AG1 is giving away 6 free travel packs of AG1 and a bottle of vitamin D3 K2 with your subscription. Again, that's drinkag1, with the numeral1.com/Huberman to get 6 free travel packs and a bottle of vitamin D3K2 with your subscription.
Thank you for explaining that so clearly, because I don't think anyone has ever explained how exactly gut health is signaling cardiovascular health, or pushing or pulling down on or raising cardiovascular health. As a neuro guy, I think about the vagus nerve as the primary conduit between gut and brain. And I was recalling that LPS injected into the gut is how you actually experimentally induce a fever, and if you cut the vagus, no fever. So there seems to be something about the way that the gut communicates with the brain and other organs that is critically dependent on some threshold level of LPS. Thank you also for reminding us that LPS is present in the gut because we have yeast in our gut, some amount of yeast. You mentioned tight junctions, and the way I think about tight junctions, please correct me because I'm going to get some or all of this wrong, is that essentially they form like a cellular fence in the gut, and that transient opening or partial opening of these is a normal process. But it sounds like after a meal, some bacteria, when you say leaks out into our system, it's literally going into the bloodstream. So now we have bacteria circulating, and if some of that is small enough to get across the blood-brain barrier, that's another way that bacteria can start to cause inflammation at the brain level.
It's LPS, which is like the outer component of bacteria that have died. Actual live bacteria getting in, I don't know as much about that, perhaps as well, but I know that the LPS is getting in. And I do know that the LPS, activating the immune system and stuff, and the resident glial cells and stuff in the brain, does break down the blood-brain barrier. It's like we know neuroinflammation is really some of the early parts of breaking down of the blood-brain barrier, which is the early stages of neurodegenerative disease. It is how the gut health is linked to the brain and to neurodegenerative disease as well. So it's the inflammation, I think, that's really it's really powerful in terms of it's a driver of the aging process in general. Like this inflammaging. You've heard of inflammaging. I think now it's pretty clear to me that is, if you're thinking about the molecular events that are leading to these hallmarks of aging, which lead to the phenotypes and, frailty and the diseases, right? Like type 2 diabetes, cancer, Alzheimer's disease, like go upstream of that. And the inflammation is at the core of it. And so we hear this word inflammation a lot, and it's like, what does it mean? And it means a lot of things. It's not just the gut. The gut is a component of it, but there's other things as well, right? I mean, you can have stress, any emotional stress, like that can lead to inflammation, not getting enough sleep, right? There's a lot of things that can lead to inflammation. And so it is kind of an important point to think about is really like trying to have your inflammation low, right? And how do you do that?
I'm going to take 3 different jumping off points here, all related to what you said. So don't think I'm a random subject generator here. We will get back to fasting, I promise. Lately, you've posted a bit about glutamine as a potential tool to perhaps buffer the immune system under times of stress. I've also been interested in L-glutamine as a way to reinforce tight junctions in the gut. I don't know if that literature is robust or not. I have to say, I started taking L-glutamine years ago in times when I was working a lot and not sleeping enough because someone told me it would help me not get sick. And indeed, I didn't get sick as much as the imaginary control experiment that I never got to do. Meaning, I don't know if it helped or not, but I continue to take L-glutamine when I'm feeling run down. I take a couple of other things too. But could you tell us about how L-glutamine is important for gut health, and if and how L-glutamine might be helpful for reinforcing the immune system?
There's not a ton of evidence in terms of like what's in the scientific literature supporting these statements, but there is some, and it's enough to kind of go, well, I'm going to try to maybe experiment with it. So, I first became interested in glutamine because when I was doing my graduate research, I was doing a lot of cancer metabolism studies, and I would do nutrient withdrawal, and I would, remove glucose from cancer cells and see what would happen. And it's like, okay, well, I would remove glucose from lymphoma cancer cells in the Petri dish, and a lot of them would die, but they wouldn't all die. And I was like, why aren't they all dying? Turns out, well, they had glutamine there. So glutamine was enough to sustain them. And so glutamine can be converted into many things. So glutamine can be an amino acid, right? It's an amino acid. Glutamine can be converted into the the Krebs cycle, so it can be converted into intermediates that are used to make energy by the mitochondria. And glutamine can be converted into glutamate, right? Neurotransmitter, right? So there's a lot of pathways and different fates for glutamine. So I became interested in that because it was like, oh, glutamine's important for the survival of these cancer cells. Then I was doing a lot of activating immune cell studies. As you know, my graduate advisor is an immunologist by training, and so I was also doing that. Turns out glutamine was essential for the activation of immune cells. So that was kind of always in the background of my mind. And then in my postdoc, I did my postdoc with Dr. Bruce Ames, and my colleague, Dr. Mark Shiganaga, was doing a lot of gut work. And this is why I know a lot about the LPS and the gut. Like, it's from him, like, brilliant guy. He's now a photographer, like, not in science at all, but brilliant guy, and did a lot of really amazing experiments looking at, you know, gut permeability and things that can help buffer, you know, gut permeability. And one of those things were glutamine. So glutamine can get converted into these intermediates that are used by mitochondria in the gut epithelial cells. And so that's like an easy source of energy as well for the gut. Now, these are all animal studies, right? So take it with a grain of salt, right? Like, because at some point, you know, in my opinion, animal studies are really important for understanding the mechanism behind why things work. And we need human studies, you know, as well. Looking at the totality of evidence is important. It's the human studies that we're lacking. There's not a ton of them there. The ones that I have found more compelling, not necessarily, I mean, with the gut health, it's you know, it's sparse with humans. I found more compelling with respect to glutamine in human studies was the immune system. And this is where I started connecting the dots, right? Where I started coming across this literature of these endurance athletes who do get a higher amount of respiratory tract infections. You know, like, when I mean endurance athletes, I mean these guys that are like out running marathons all year. Like, they're just constantly training for a marathon, right? And so they're really like, they're putting a lot of demand, right? Energetic expenditures happening at a really high rate. So they're more prone to respiratory infections. And there's a few studies out there showing that if these athletes take a higher dose of glutamine, I think it's like 30 grams or something high like that, that they had a lower incidence of respiratory tract infections compared to the ones that weren't doing it. And then I went back to I know that glutamine is really important for T cell activation. And I was like, I'm going to take this because being a mom and having a child that's bringing everything home like a vector, you know, you're like desperate.
You're the experiment.
Yeah, exactly. And I never used to get sick, ever. Like, I would never get sick. And then all of a sudden I was getting sick like 3 times a year. And I was like, do I have cancer? Like, what's going on? Like, I literally was like worried. And then I started taking glutamine. Now, I only take 5 grams on a daily basis, but if my son's sick, if there's any exposure, if it's like during the season, if I'm traveling, I go up to 15, I go up to 20.
All at once? Because it can be a little hard on the gut, right?
Not all at once. Yeah. Not all at once. I usually do it like in 5s. So I do 5 grams, 5 grams, 5 grams. And, you know, I have to, with the caveat of I do that, but I also take a lot of creatine as well. And so I don't know which one or both, but like, I really don't get sick. I'm not getting sick. And even if it's brought home in my house, I'm not getting sick. And maybe it's a placebo. And you know what? I am A-okay with that because placebo effect is real as long as I'm not getting sick. So I think with the glutamine, you know, it's not something that I would feel comfortable saying that there's a lot of evidence, it's overwhelming, and with confidence that it's improving gut health and it's improving immune, you know, it's going to help give your immune cells energy, particularly if they need to be activated, you know, upon exposure to any pathogen. But I feel like it's worth experimenting with. Perhaps maybe if someone has colon cancer, that would be more of a concern because I did mention that cancer cells love everything, anything that's good for you, right? Folate, I mean, if you don't have enough folate, you can cause double-stranded breaks to your DNA, which lead to mutations that lead to cancer. But if you have cancer and you take a bunch of folate, you need folate to make new DNA, and so they like the folate, right? So it's like...
It's an abnormal growth. So anything that's associated with growth.
Proliferating.
mTOR. I saw the recent study on taurine, which scared a lot of people because taurine's in a lot of energy drinks, but that was an in vitro study. Yes, I was going to ask, you know, is there increased cancer risk if you're supplementing with glutamine because cancer cells love glutamine?
So my personal opinion, I'm obviously not a medical physician. This is not a prescription. It's just my opinion. I personally am not scared of getting cancer from taking glutamine. If I had a colon tumor, a tumor in my colon, the first site that the glutamine is seeing, maybe the liver as well, since that's also the next step. But barring like having a tumor already in my liver or in my colon, Those would be the only, types of situations that I would be worried about taking glutamine. I don't think it's going to cause cancer, right? Now, I guess the question is like, what if you don't know you have?
Well, hopefully the cost will come down on whole body MRIs. Actually, the cost is coming down on whole body MRIs, that hopefully more people are able to get those. It's not just such a high-end exclusive thing in the near future. Kind of like blood draws. Used to be like panels of blood testing. You only got them if you really needed them. Now the cost of blood draws is really low.
Right.
So hopefully people will be more aware. Yeah, I will take a tablespoon of glutamine once or twice or 3 times a day if I'm feeling run down. You mentioned being exposed to pathogens from vectors of different sorts. Before we went on mic, we were talking about NAC, N-acetylcysteine. I take it once a day consistently, but I'll take it 3 times a day if I'm traveling a lot, because I'm around sick people when I travel, especially in winter, or if I feel like I'm getting run down. And there the data are pretty interesting. There's at least one study showing that it reduced flu transmission where people were deliberately exposed to flu. I think it took the number of people that contracted flu compared to the placebo group somewhere from the high 70% area, I don't remember the exact number now, we'll put a link to the study, down to maybe high 20s, which is pretty impressive. And an ER doc came on this podcast, Roger Schwelt, who and said he was a big proponent of N-acetylcysteine for people that are around sick people. Do you take NAC?
So my only concern with taking it on a daily basis is it is a pretty powerful antioxidant. And, I think that we need to understand like antioxidants and the opposite, which should be generating oxidation, right? Like it's not like oxidation is bad. It's bad when it's constant slow drip oxidation that's damaging, other parts of our body, DNA, proteins, lipids. Some oxidation you want, like if you're exercising, right?
Sure.
There's a burst of oxidation.
To get the adaptation.
And so my concern would be, for one, maybe timing it around your exercise, so not taking it close to when you're exercising. And these studies come out of, studies that have been done with high-dose vitamin E plus vitamin C. I haven't seen a lot of vitamin C studies alone that are blunting exercise adaptations. There's maybe one at a high dose. Most of the time it's vitamin C and vitamin E, alpha tocopherol. When I say high dose, usually it's 400 IUs. Just to give you a reference point, the RDA is like 24 IUs or something. So we're talking high dose.
But a supplement can be 200 to 800. So it wouldn't be hard to blunt that exercise effect by accidentally. Yeah, I don't take vitamin E. It spiked my prostate-specific antigen, which I was told is a known effect among urologists.
The SELECT trial was done. So the SELECT trial was looking at selenium and vitamin E, and if it could slow the progression of prostate cancer. And it turned out that the opposite was found, and it was really kind of due to this high dose of alpha tocopherol, which also has other effects of lowering another type of vitamin E in the body called gamma tocopherol, which is anti-inflammatory. And I think that has something to do with inflammation, actually can increase the PSA, right? So anyways, the point here is that with NAC, my only concern would be, blunting the oxidation that you're getting from beneficial, because I know you're highly active.
I'm training hard. I don't want my training to be short-circuited from NAC. I'm perfectly happy to only take NAC if I'm feeling run down or exposed to illnesses around me, or I feel like
that's
maybe
when
I'm coming down with something.
I take it, but it's mostly because of I wasn't familiar with the influenza data. That's interesting. It's good for lung health too. Although if smokers take it, I think it has the opposite effect where, again, it's like the precancerous cells are using it to their benefit. We used to think antioxidants, it's so good, just more. And it turns out it's not the case, right? And that's why a lot of these other types of hormetic stressors or plant phytochemicals, they're actually generating an antioxidant response endogenously in our body by activating these antioxidant pathways, which are so much more powerful than what you would get from an antioxidant, right? And so that's and it's not like you don't want some antioxidants. It's just like you don't want to overdose on taking too much NAC and too much vitamin C and too much vitamin E, because there's also something called reductive stress. So we know about oxidative stress. Oxidative stress is when you're causing these reactive oxygen species to damage things like your DNA, for example, and over time, eventually that happens in a part of the gene that can be oncogenic and lead to cancer. Well, reductive stress is like the opposite of that. So it's like too much of the reducing equivalents, like the NADH, the NADPH, so and it also has negative effects. So you kind of don't want to go too far on either ends of the spectrum. But also you want to, instead of having this like slow leaking effect of these pro-oxidants that are happening from eating a bad diet, from inflammation, things like that, you want it to be a short burst where you switch it on, you have the adaptation, it's off, right? And the adaptation happens in the recovery period, right? When you're, for example, if you exercise, that's a big burst of reactive oxygen species that is beneficial, and you want it, right? And you don't want to blunt those adaptations. And so that's kind of my concern with daily dosing of NAC.
Great. I don't cold plunge in the 6 to 8 hours after resistance training for exactly the reason you're talking about. Yeah, I want the inflammation. I want the increased blood flow. I don't want to short circuit that. I'm perfectly happy to only take NAC under conditions where I'm a bit run down, and that's also when I'll take glutamine. If you take L-glutamine regularly, I personally observe that I get stronger at a steady state of starch intake. And I don't like dropping starches too low because I get weak.
Yeah.
And I also can't sleep as well if my starches are too low. I just am too wired.
Yeah. There was a new study on eating starches and improving sleep.
Yeah, and I'm so grateful for that because for several years I talked about that on the podcast, and people said, oh, he's gorging himself with pasta and then passing out, and that's the worst time. I wasn't saying that. I'm saying that if you're running like crazy, I'll hear from marathoners and ultra people, and people are doing a million things. They'll say, I'm not sleeping well, and they're exercising like crazy. It's like, well, when was the last time you had a bowl of pasta? Like, oh no, I don't eat pasta. And then they'll have some rice or some pasta. Like, oh, I slept like a baby. And they were having it at lunch.
Yeah.
And I just think that the brain doesn't shut down well when you have high levels of cortisol. And the cortisol starch thing is an interesting one.
I'm so glad you brought this up because I think this is something that I did want to talk about really, and it has to do with stop eating 3 hours before bed for that very reason. So there was a new study, but there's been several studies now really showing that this is important for that cardiovascular reset, right? Your parasympathetic activity is supposed to go higher. You're in your rest and recovery phase, right? When you're eating food, that's the sympathetic activity, right? That's activating the sympathetic nervous system.
As you're eating.
Yeah. And even as you're digesting. So you have to think about it. Like you digest, it takes like 5 or so hours to fully finish about.
Yeah, depending on the meal. Yeah.
Depending on the meal, right. So if you're eating, right before you go to bed, you are not in that parasympathetic activity, part of the cycle that you want to be in. So there was a new study that I shared a couple days ago even, showing that if you stop eating 3 hours before bed. So these people were actually, it's interesting, they had their blood pressure measured for starting in the mid-afternoon all the way throughout the night. This is the first study that really, not just one endpoint looking at blood pressure, but just measuring it continuously. I don't know if it was every 15 minutes or something like that. But it was found that during sleep, if they had stopped eating 3 hours before bed versus the group that did not stop eating 3 hours before bed, their blood pressure dipped lower. So you get that barrow reflex dipping, right? So this is part of the parasympathetic activation. As you know, very important for the blood pressure to go down. Heart rate went down much, much lower. And that reset is so, so important for cardiovascular health. I think what was found was it was something translated to 20% lower risk of cardiovascular events, like heart attacks. So it's really pretty significant. Yeah. And it really is an easy thing to do, to think about stopping eating, 3 hours before you go to bed. That's something I think that is not that hard to implement. And it will improve your sleep as well as your cardiovascular health. Although I think in that study, I don't know that sleep was it was subjective, and I don't think it really was improved more. But other studies have found that as well, that sleep does improve. I know Sachin Panda, he's been on my podcast, your podcast, he's had studies showing that it seemed like stop eating 3 hours before bed really does seem to improve sleep. But this parasympathetic activation, you don't want to have a meal right before you bed because you want to be in the rest and recovery part, right? So
yeah, I think people hear, and I understand why the nomenclature and the buzzwords of, fight or flight for sympathetic and rest and digest for parasympathetic. But yeah, the evidence shows eating stimulates the sympathetic nervous system.
Yeah.
It's not a stress event, but it requires energy. Anything that requires energy raises body temperature, and your body's doing work. And
it's an awake event.
An awake event.
It's an awake.
Right.
You don't
it's a
eat
great way to put it.
while you're sleeping.
Yeah, and that's why these phrases, while I don't demonize anyone for creating the fight or flight, Well, I mean, there's ways that you want your sympathetic nervous system activated that are not about fight or flight. Like, I actually think if people just got the first hour of their day more active and energized, bright light, exercise, caffeine, if you're me, and Lord knows I'm grateful that caffeine exists, in the first hour of the day, or first hours if you can't manage that because of schedule, and then the last hour of the day was strongly parasympathetic, I mean, everything would get better without having to think a ton about exactly how you're doing that, because on a given day, you just do what you can.
And that's what you want, right? I mean, so cortisol is circadian dependent, as you know. I mean, in the early hours of the morning, that's when you want it to peak, right? The part of the awakening response, like you want it to go up. And it's interesting. The reason I'm going on this is because it's a little bit of a soapbox for me. But so with the cortisol activation, people don't realize this. You know, obviously it's a hormone and it's binding to two different receptors. There's the glucocorticoid receptor, and then there's the mineralocorticoid receptor. And both of those, when cortisol binds to it, they go into the nucleus of the cell, and they're changing the expression. So they're activating genes and deactivating genes, like 20% of the human genome. It's a large percentage, right? And this is on multiple different organs. So cortisol has a very important role. And you want that peak. You want that spike, right? That's what you want. And then you want it to shut off. And there are things that can activate it, obviously, like in the morning, going out, bright light exposure, as you mentioned, like that's very important for that cortisol awakening response. But you can also, intense exercise can switch it on. But what's interesting, and so can intermittent fasting, what's interesting is there's studies from Mark Mattson's lab showing that, you know, the types of stressors that are beneficial, these hormetic stressors like exercise, like, you know, intermittent fasting, perhaps even cold exposure, like these types of exposures change the receptor density of the receptors. So if you look at what activates cortisol in a negative way, chronic stress, let's say emotional, financial, psychological, chronic sleep deprivation, right? That bad type of stress, you're not getting a big spike, you're getting a slow drip of it. And so what happens is when you have that type of stress, you're increasing the glucocorticoid receptors and you're decreasing the mineralocorticoid receptors.
Interesting.
There's a different biological response in the brain, in the hypothalamus, but also in other organs as well. When you're activating cortisol through a beneficial type of stress, the hormetic stressors like intermittent fasting, like exercise, I believe probably deliberate cold exposure as well, where it's a different biological response. And also, if you think about it, you know, you actually want cortisol to do its, you know, function. You want it to change the expression. That's what it's supposed to do, right? The problem is when you have that slow drip, then, you know, not only are you're increasing, they're changing the receptor, you know, activation, but also they become resistant to the cortisol. And so you're not getting the benefits. Cortisol represses inflammation, right? It suppresses the immune system. But so you're not getting that anti-inflammatory effect from cortisol. It's being dysregulated. And that's what you don't want. You don't want cortisol to be dysregulated in terms of the genes that it's supposed to activate or deactivate. You want it to be doing what it's supposed to. It's supposed to regulate. We're supposed to have the cortisol, activation response. So anyways, that's something that I kind of want to clear in people's minds, because I feel like a lot of people get worried about, oh my gosh, I'm doing, HIIT and it's activating my cortisol. Well, that's fine. It's I guess if you do too much HIIT, right, you can always take something to the extreme. Okay, with that caveat, obviously I'm not talking about that. But with that caveat, you want your body to be able to turn it on and then turn it off and have the adaptation, have the response, right? And like I said, it's a different biological response than the chronic type of cortisol activation that you get with the bad types of stress.
Yeah, I guess same goes for intermittent fasting. And maybe you could share with us what your intermittent fasting protocol is. I know that recently cortisol has been increasingly demonized as the stress hormone, and people saw pictures of people with Cushing's disease, which is, a drastically elevated cortisol, and the moon face and the excessive visceral fat, and this sort of fear-mongering around cortisol was particularly directed toward women. And this entered the health fitness space because I think in an appropriate way, I'll just be very direct here. I no longer tap dance around who said, in a very appropriate way that I appreciate, Dr. Stacy Sims came on the podcast and she said, listen, some women shouldn't train fasted because they don't feel well when they train fasted and their cortisol is too high and so forth. That captured a lot of people's experience. a lot of women in particular, but some men certainly were like, yes, oh my God, thank you, thank you, thank you, thank you. But then the message got contorted, right? As it does,
Yes,
right?
yes.
And then it became women shouldn't train fasted. And then we had Lauren Colenso-Semple on this podcast, who's trained as a PhD. She has a background in nutrition, physiology, strength training coach, et cetera. And she said, no, listen, you can train fasted or not fasted as a woman or a man. It's kind of your preference, but that we don't need to fear these cortisol spikes. And forgive me for going long here, but I think it is important that people hear this again, which is, there's also this idea that deliberate cold exposure increases cortisol, but when you look at the data, it definitely increases adrenaline and peripheral dopamine, and probably, I'll go on record, probably central dopamine, although we don't have as good evidence for that yet. But their evidence points to the fact that deliberate cold exposure lowers cortisol. So this then, because, and again, I think Stacey appropriately said, a lot of women who want to use cold shouldn't go as cold, but the message got contorted and it became women shouldn't do deliberate cold exposure because of the cortisol increase. And so part of the reason I'm going long here is I'm trying to correct the narrative on her behalf. She said, do what works for you, right? And that's what Lauren's saying, and I'm guessing that's what you'll say as well. But I just need to get that out there because the message has gotten totally pretzel twisted up, and cortisol is neither good nor bad. You want it high in the morning, you want it low at night, in general. It sounds like you train fasted.
I listen to how I feel. That's exactly what I do. So what your podcast guest and the researchers are talking about is exactly, there are times when I wake up in the morning and I'm like, I need to eat something before I work out. And I do. But I oftentimes do train fasted, for one, because I am practicing intermittent fasting again, but I do it, I'm not like starving myself. And like I said, there's multiple reasons I do it. One reason is because it really did help me lose the belly fat, which is the visceral fat, which is like the worst kind of fat you can have. And we can talk more about that. But the second reason is I love the cognitive benefits I have in the morning with it. And it's the main reason I do it. And so there are many times when I do train fasted, but I am not out running 15 miles. Most of my, like I said, my sessions are about an hour long. And am I taking a little bit of a performance hit with the high intensity? Probably, yes. But it's not much to matter for me. And you do burn a little bit more fat if you train fasted. I mean, that's known. You will, if it is a longer session, you will take an performance enhancement hit. That is also known, right? So I think it really does come down to like, what is your goal? How do you feel? And then you kind of go with that. And I completely agree. Like there are times when, I'm on my cycle and I feel fine and I'm working out just fine. And there are other times that I'm like, I don't feel good. Like I'm gonna take it easier. But I still train. You listen to your body. And that's a pretty easy, I think, rule of thumb. Sometimes people like to complicate things, there's lots of reasons why. We don't need to get into that.
I have theories. I have theories, but they're not important right now.
No, it's not important. Yeah. So I do train fasted, and it is, for me, it is helped me tremendously change my body composition. Like I said, I'm in a different part of my life than perhaps a 30-year-old woman is, right? So when I was 30, I mean, like I didn't have to train fasted. It was easy to keep, the belly fat, the visceral fat lower. Hormonal changes do play a role in the way your body, so estrogen plays a role in telling your body how to store fat. So subcutaneous fat would be the kind of fat that you can just like pinch, right? The fat that we see. The visceral fat, that's that deep fat that's lining your organs. It's often belly fat, and it's lining the intestines, the liver. It's almost like an endocrine organ. I mean, because it is secreting hormones. It's secreting inflammatory factors. It's metabolically active. It's constantly breaking down triglycerides. It's associated with double the risk of early death. People that have high visceral fat have 44% higher chance of having cancer, many different types of cancers.
Wow.
It's huge. It's huge. And of course, insulin resistance is the number one problem with visceral fat, right? And I'd love to talk about that. But if you want, I mean, we can get into that. Yeah, it's so with the visceral fat, and like I said, visceral fat is something, if you really directly want to measure it, you do a DEXA scan. But, for the average person that isn't going to go out and do a DEXA scan, waist circumference is a proxy. It's used in a lot of studies. So women that have a waist circumference of 35 inches or above are considered to have a higher amount of visceral fat. men that have a waist circumference of 40 inches or above are considered to have a higher amount of visceral fat. It's also that belly fat. Like you just know, right? Interestingly, like 70% of women over the age of 50 have high visceral fat. 50% of men over the age of 50 do. Again, coming down to women go through menopause. Estrogen plays an important role in telling the body, to store the fat subcutaneously rather than viscerally deep around organs. And so as women transition to perimenopause, the years before menopause and menopause, their estrogen goes down, and that does change the way the body stores fat. And any woman that's going through either of those stages knows it. And it's also why you see often women over the age of 50 with more belly fat, right? I mean, that's something that I think it's hard to deny. But it's one of the reasons why I kind of went back to practicing intermittent fasting, because there's a couple of ways that you can really powerfully lose visceral fat. And one of them is doing aerobic exercise. High intensity interval training also really powerfully can do it, but also being in a caloric deficit. And I think when you start to get the combination of both, that's what really worked for me. It's crazy how quickly you can gain it based on your diet as well. So it is different from the subcutaneous fat in many ways. I've mentioned it's secreting these inflammatory molecules, it's hormones, but it's also constantly breaking down triglycerides into free fatty acids. And the location of it is very dangerous because it's right surrounding the liver, right? It's this deep organ fat. And that's very close to the portal vein. And so you're constantly getting this sort of mainlining free fatty acids to the liver. And visceral fat is very different from subcutaneous fat because it doesn't respond to insulin like subcutaneous fat does. In other words, when you have a meal, you eat a carbohydrate meal, and your body increases insulin to help take it up glucose into your liver, muscle, adipose tissue. Lipolysis shuts down, right? It's like, okay, no longer am I going to break down these fats. It's time to use this energy, right? Visceral fat doesn't respond to insulin, so it just keeps going, right? And these free fatty acids, because they're going right to the liver, it's essentially antagonizing the insulin receptors. So it causes insulin receptors to become more resistant to insulin. And this is part of why people with high visceral fat, by the way, you can gain visceral fat without gaining a pound. And we can talk about those studies. Like people are skinny and can have high amounts of visceral fat. You've heard of like lean, metabolically unhealthy but lean individuals. Those people exist. And so you can have a high amount of visceral fat but not really look like you do. So when, obviously the insulin resistance is a problem for many reasons, but it also plays a role in those energy crashes that you experience, right? And that's kind of like some of the first signs of insulin resistance actually have to do with what you're feeling. So we talked about lethargy, right? So, the inflammation that's being generated from this visceral fat constantly making these, pro-inflammatory compounds it's an energy sink, right? So you do constantly feel tired, but also because your cells are becoming insulin resistant, when you have a high glucose meal, and you're not responding, the body kind of overcompensates and produces more insulin. So it's like, we got to get this blood glucose out of our system, right? It can cause a lot of damage if it sits around there. And so you make more insulin. And then what happens is your blood glucose goes way low because it was like this overcompensation, right? And then you feel a crash. You feel like this crash. And that signals to the, hypothalamus part of the brain. I need energy, right? So then you sort of crave, you get those cravings for those calorically energetic, dense foods. What I'm talking about is like the experience of like, insulin resistance. And what's interesting is that you can cause someone to gain visceral fat and their brain can become insulin resistant. So we think a lot about insulin resistance in the muscle, liver. Your brain also can become insulin resistant quite quickly, actually. So insulin's very important in the brain for a lot of reasons, as you know. But, a couple of the things relevant to what we're talking about would be, one is it does act on the hypothalamus and help, tell it to basically stop eating, be satiated. Like I took a meal in, okay, like I'm going to be satiated. But it also plays a role in energy storage and telling the body how to store the energy. And so when your brain becomes insulin resistant, it's not doing that. And so you're not being satiated, so you eat more, and you're storing the fat more viscerally. And there was a study that was published actually quite recently. I covered this in a recent newsletter. It was a really interesting study because it was healthy young men, and researchers put them on a little bit of a calorically dense. So it was like they were eating 1,200 to 1,500 more calories a day, and it was high saturated fat, high sugar. So it was the processed foods, ultra processed foods, like, ultimate, right?
That's a lot of extra calories.
It's a lot of extra calories. Of 5 days. It is. But what happened was they did cause their brain to become insulin resistant, and they didn't gain weight, but they gained visceral fat. And they started gaining fat around their liver. And that's something that happens as well because visceral fat is surrounding liver. You're getting a lot of free fatty acids, and they're going right to the liver. So the liver has to store it, right? So you get this non-alcoholic, fatty liver. And that happened after 5 days. I mean, without gaining.
In otherwise young, healthy.
Yeah. But, they were eating a lot of calories, extra calories.
Yeah, that's like a 1,200, that's like a half a pizza extra above your maintenance
and that's
calories
probably
per
what
night.
they were doing. They were eating they were eating like saturated fat and refined sugar. So
Burritos and French fries.
Yeah, I mean, obviously, if you're going to do the study, you want to kind of do it to a degree where you're going to see some change, right? So maybe it's not going to happen in 5 days if you're only eating 500 more calories a day, but over time you will be gaining visceral fat, right? So it's not going to be the same degree. It's something to be concerned about. It's something to think about. And also because you can gain it and not really even know it, without gaining a pound. And there are other things that cause it, not just, eating too many calories or diet composition. I mean, you mentioned cortisol. I mean, chronic elevated cortisol makes you store the fat around visceral fat. Sleep loss. I mean, there's also studies showing that you take healthy men, sleep deprive them for a couple of weeks. I think 4 hours, they're getting 4 hours of sleep a night. They can start gaining visceral fat. I mean, pretty rapidly with only gaining a pound of weight. So again, it's not necessarily something that you're going to see on the scale, but it's happening, right? And it's affecting your short-term mood. I mean, how you feel, your energy. It's affecting, the way you're eating. It's a vicious cycle because you start to eat more calories, right? And then it just becomes this vicious cycle of that you start to gain more visceral fat.
I'd like to take a quick break and acknowledge one of our sponsors, LMNT. LMNT is an electrolyte drink that has everything you need and nothing you don't. That means the electrolytes, sodium, magnesium, and potassium, all in the correct ratios, but no sugar. Proper hydration is critical for brain and body function. Even a slight degree of dehydration can diminish your cognitive and physical performance. It's also important that you get adequate electrolytes. The electrolytes, sodium, magnesium, and potassium, are vital for the functioning of all cells in your body, especially your neurons or your nerve cells. Drinking LMNT makes it very easy to ensure that you're getting adequate hydration and adequate electrolytes. My days tend to start really fast, meaning I have to jump right into work or right into exercise. So to make sure that I'm hydrated and I have sufficient electrolytes, when I first wake up in the morning, I drink 16 to 32 ounces of water with an LMNT packet dissolved in it. I also drink LMNT dissolved in water during any kind of physical exercise that I'm doing, especially on hot days when I'm sweating a lot and losing water and electrolytes. LMNT has a bunch of great tasting flavors. In fact, I love them all. I love the watermelon, the raspberry, the citrus, and I really love the lemonade flavor. So if you'd like to try LMNT, you can go to drinkelement.com/Huberman to claim a free LMNT sample pack with any purchase. Again, that's drinkelement.com/Huberman to claim a free sample pack.
Such an important point that you can either not be gaining much or not gaining any total body weight, but gaining visceral fat. I think that's first time I've heard that, and it's a vital message for people to hear because this visceral fat sounds like one of the major health hazards we need to worry about. You mentioned chronically elevated cortisol, sleep deprivation will increase visceral fat. Once again, I know I'm beating a drum here almost to death, but having high cortisol early in the day and low cortisol in the evening is the definition of not chronically high cortisol. The definition of chronically high cortisol is somewhat elevated or elevated cortisol in the morning, but especially in the hours before sleep. And I actually have a theory that is not a stretch that one of the main reasons why it's so detrimental to our mental and physical health in the short and long term is because of the ways it disrupts sleep. And so, and we can't tease those apart.
No.
You can't do a study where you spike cortisol late in the day. Even if you can fall asleep just fine after the end of a really stressful day, the sleep is different. And people say, well, life has stress. And I totally agree. I mean, Lord knows I've experienced life has stress. But getting that last hour of the day, doing things to push down on cortisol, push down on stress, lower heart rate, not eating, and certainly that last hour before sleep, ideally 3. I feel like that small change can make an outsized positive difference.
That's interesting, like the correlation between the high cortisol affecting your sleep, and maybe that's also like they're related, and so the sleep loss really does make you. We know from, you probably know who the researchers are that have done those studies on sleep loss and it affecting appetite, right? I mean,
everything gets dysregulated.
Right.
I mean, I don't want to take us off course, but I think you might find it interesting that there's a beautiful study where they measured metabolism during sleep. They basically had people breathe into a tube during sleep. They had a mask on, and it turns out that the brain cycles through all the different forms of metabolism during sleep. There's a phase of sleep where you're essentially running on sugar. There's it almost looks like somebody's ketogenic at one. Basically, the middle of the night when it should be at night, when you're sleeping is kind of a test run of all the systems, but they get recalibrated. And it's so important. I actually think, most of the negative effects of alcohol that people talk about, yes, it's a poison. It's a class 1 carcinogen, as classified by the World Health Organization. I think most of the negative effects of drinking are because of the negative effects of alcohol on sleep. I'm not telling people drink in the morning, but, and so I think that if you get your sleep right, you're not 90% of the way there, but you're halfway there.
Yeah.
I really do believe that. And then getting your sleep right makes you do a bunch of other things.
Right. You're more motivated to exercise, for one.
More motivated to exercise, your food choices, and on.
Yeah.
The problem with talking about sleep is so important is people will get sleep anxiety. So we tap dance around this, like, we don't want people stressed. Learn how to fall asleep, learn how to fall back asleep. No one gets it perfect. Yes, you'll survive. Like, without one poor night's sleep or an all-nighter, you're not gonna die. Like, just get good at it on average, right? That's what I'd say. Could you tell us what the structure of the intermittent fasting is for you? Does that mean skipping breakfast, skipping lunch, skipping dinner? Because I know a number of people are sort of getting drawn back to intermittent fasting after a couple of years of it getting beat up on as like not the best way to lose fat, or I think it's a terrific way to do the sorts of things that you're describing, and I'm learning today more about the positive things it can do for insulin sensitivity and so forth. If you're on a bout of intermittent fasting, are you doing it by the clock? Are you doing it by feel? What does it look like?
For me, it really does depend on the day, and I really do try to stop eating 3 hours before I go to bed. It doesn't always happen, with family obligations, social obligations, but it's the habit that's important, right? So intermittent fasting, it's more than just one intervention, as I mentioned. It's a behavioral tool that you can use to limit your calorie intake without actually having to count all the calories, which some people like to do, some people don't, right? So it's a tool, but also it's really important for a metabolic switch. As you mentioned, insulin sensitivity. And the metabolic switch is something that Dr. Mark Mattson coined, and I love it because I feel like, thinking about intermittent fasting in that way makes it a little more clear as to the benefits of it. It depends on the meal you have and how much exercise you do, right? But on average, let's say 11, 12 hours to deplete your liver glycogen levels. And once that happens, you do start to burn fat and use fatty acids as fuel and make ketone bodies. So you go into ketogenesis, right? And that's a metabolic switch. Metabolic flexibility. You're going from using carbohydrates as fuel to using fatty acids and making ketone bodies as fuel. And that's something that, throughout human evolution was ingrained, right? Like we didn't always have access to Uber Eats and Instacart, and you just, at a swipe, you get food, right? There were many times when, people had to not eat because they couldn't forage their foods, maybe the time of year, or they couldn't hunt their food because they didn't get a win or whatever. I don't know. So this metabolic flexibility is something that's really ingrained in our DNA in a sense, right? One of the reasons I like to do that is the ketone production. And why is that? Ketones are really clean. They're a clean way to burn energy. So they generate less oxidative stress, less oxidative products, but they also are energetically favorable in that it takes less energy to use them to make energy than glucose does. So it takes more energy to use glucose as energy than it does ketones. But they're also a signaling molecule. So it's a way for the body, to signal to other parts of the body, like, hey, this is a stressful time. There's no food. I'm in ketosis. Let's make you stronger, right? Because that's kind of what evolution wants. Like if you're not able to find or eat food, you have to be stronger to be able to do it, right? And so that's kind of at the, I'd say, core of this metabolic switch and why it's important. And I think that I really like Mark Mattson being the pioneer in this. And as a neuroscientist, really looking at the benefits in the brain as well. You know, these ketones like beta-hydroxybutyrate are activating, you know, growth factors like brain-derived neurotrophic factor in the brain. As you know, it's very important for, you know, learning, memory, you know, synapse formation and stuff. That's hugely important for neuroplasticity. So it's activating beneficial compounds like that. And again, it's not going to happen if you're never going into this metabolic switch. And there's other ways to get there, right? So you can limit your food, go into this ketosis, right, where you're basically depleting your liver glycogen, or you can exercise a lot, right? So your energy expenditure goes up. So there's different ways to get to this metabolic switch. It doesn't necessarily have to be intermittent fasting. And I'm telling you this because I want to tell you why I'm sort of back on the intermittent fasting. And by the way, it's not for everyone. Like I said, I mean, I think that you can find other ways to get this metabolic switch. And for me, intermittent fasting works. And so what I do typically is I will do most of the time my workouts will be fasted. Not all the time. It does depend on how I feel.
What time do you typically wake up?
So I wake up like between 6 and 7. And if I didn't have a family, like, you know, getting my son ready, and I would probably work out right away. But I don't end up working out until like 8:30. So I'm, you know, and
still pretty early. What time do you go to sleep, if you don't mind me asking?
I'm asleep by 10. I'm usually in bed at 9. Takes an hour of just like, you know, hanging out.
Sure.
And yeah. So or 9:30 sometimes. But yeah, usually 10 o'clock is when I'm sleeping. That's my bedtime. And so I do stop eating. I try to stop eating by 7 p.m. But typically my first meal it depends on the day, but it'll usually be like around 11, maybe sometimes 12. If I'm doing a podcast, it'll be later. And I do like to be fasted in the morning because the cognitive benefits is really what I'm interested in with that metabolic switch. And it does come down to ketones. And I know that Mark Mattson's talked a lot about this. I had him on my podcast a few years ago, actually. I learned so much. But the ketones like beta-hydroxybutyrate are increasing GABA. They're like balancing the glutamate, the, you know, excitatory neurotransmitter with the inhibitory one, GABA. And I think the increase in GABA is what helps me and what I love the most, because it does help, I think, quiet down some of the other, I don't know, chitter chatter in my brain and help me focus, because it's like somehow the GABA is calming in a way. I don't know exactly. You could probably describe it better than I can. All I know is that I really like it. And so in the mornings, I like to be fasted. I like to be cognitively aware. It's when I get most of my productive work done. And I feel smarter. So I'm doing it. And that's why I typically like to shift my breakfast to later. Now, I would say some days I do only eat 2 meals where I am, honestly, I'm skipping the quote unquote breakfast. But some days I do have 3 meals. And, you know, oftentimes they're like different sized meals, right? And usually if I do have 3 meals, the third one will be the in between the first meal and the second meal will be like a half or 3/4 of a turkey burger or something. So it's mostly protein and it's not heavy. But so I would say I'm, you know, usually 11 to 7 probably is when I'm eating my meals most days. Some days it's, you know, I fast for a shorter period of time. Some days I wake up in the morning because I did too early of like, I'd stopped eating like 4 or 5 hours before bed, and I'm like, I need to eat. And guess what? I eat. And then I work out, and it's like that's, you know, you kind of just listen to what your body's doing. Actually, Mark Mattson just published a study very, very recently showing that he did I think he was doing a 5-2 intermittent fasting protocol where it's like 2 days you're getting pretty severe caloric restriction. Like you're eating 1 meal, but it's like 500 calories, you know, for the day. And it's twice, 2 days out of the week. The other 5 days you're eating normal. And compared that to eating like a healthy diet. And they were somewhat calorie restricted, but not quite as much as the people that were doing the fasting. And the fasting group had massive cognitive benefits, like 20% improvement in a battery of tests that were done.
He attributes that to the ketones and the effect of ketones on GABA.
He attributes it to the ketones. And like, can you get that to some degree with caloric restriction? Probably, especially the more severe caloric restriction you do. You can, if we're talking about weight loss, caloric restriction's key, right? You have to have that. If we're talking about the cardiovascular reset, like caloric restriction, if you're eating meals right before bed, you're not going to get that. Like that, those studies have been done. And I think, Courtney Peterson was one of the first ones to really show that effect on blood pressure, like really significant. In fact, if you do early time restricted eating and stop eating, I don't know how early in the day it was, maybe 6 p.m., maybe it was 8 p.m., but, there was like a blood pressure drop that was like 10, I think was points or something, millimeters of mercury.
Significant.
What is it?
Yeah.
So, I mean, that's very significant. It's on magnitude of what you'd see with like some of the first line, drugs that are used to treat hypertension. I would never say for someone to do that, but I'm just saying it's significant. And that's not something that you typically see if you're eating, fewer calories, but you're eating constantly throughout the day. So I do think there are special benefits that can be had, but again, it's also a tool that people use. I use it as a tool as well. I don't like to count calories. Like I don't, some people do, and that's fine. Then, that's the way you can do it. But I like it for the metabolic switch as well. If I were an endurance athlete running, 10, 14 miles a day, I wouldn't have to do this. That would be my metabolic switch. And it's not that I'm not metabolically flexible. I mean, I think you can just training itself, does to some degree help with metabolic flexibility, right? The ability to switch between burning glucose and carbohydrates and then using fat and fatty acids as your energy source. It's that I want that real switch to be on. And I want it to be on for a little bit of time. And then I want to turn it off by eating. I'm not starving myself. And I think you can go too far with exercise and with fasting. The problems with fasting, the people that are like, oh, fasting's terrible for you. I mean, it comes down to one, they were all about, it's like the weight loss is not just due to intermittent fasting itself, it's due to calorie restriction. Guess what? They were right. Number two, they're afraid of losing muscle. And I think we have enough data now that it's like, if you're doing resistance training, you're not going to be losing muscle. Now, maybe you won't gain as much as if you were eating more protein, but you could just eat more protein within the window that you're eating and be fine, right? So I think that's the other thing that people are worried about is muscle loss, including myself. And I train so much now, and it just works well for me. And I feel good, and it's like this clean feeling. You feel cognitively sharp, and it works. And I think that the metabolic switch is something to not be scared of, as long as you're not, again, going to the extreme, right? And if you don't want to train while you're fasted, don't train while you're fasted. You don't have to, I think there's a little bit of an added benefit that works for me in terms of burning fat, which is what particularly visceral fat. And to me, that's what works well. But you can obviously, like if you're training hard and a lot and really fasting, maybe that's too much. It's too much of a stress. So you have to kind of figure it out for yourself.
Yeah, I think the known increase in adrenaline from being slightly fasted is awesome for cognitive function. I think it allows people to ingest fewer stimulants in the form of caffeine. You don't need as much caffeine when you're doing some fasting. What you describe is similar to what I do, although I notice these days I'm waking up hungrier and hungrier, and I attribute that actually to my last bite of food, coming a little bit earlier in the day and further from sleep. And also that thermogenic effect of eating raises core body temperature, and to fall asleep, you want your body temperature dropping. So it all starts to, what I think is kind of, is very exciting to me is that for a few years there, it seemed like there were just so many things, so many protocols, so many studies. But when I think about cortisol high in the morning, low in the evening, bracketing the day, what works best for sleep, but what you're describing, certainly today you really, in addition to many other things, really clarified the relationship between gut and inflammation and brain and other tissues. Things start to fall into bins that it's, like all of biology, so beautifully organized that it doesn't mean long lists of things for people to do. I love the idea that while it sounds like you're just saying, oh, if I wake up and I'm hungry, I eat. And if I'm not, and I think I can train fasted, I like to train fasted. That might seem like an obvious thing to some, but I think it's so critical because the mechanism that you're chasing in both cases is the same. You're trying to get great sleep, great workouts, but you're not trying to optimize the workout to the point where you disrupt your sleep or you insist on doing something like eating or fasting, whatever it is. So the find out what works for you thing is so crucial because it's about feel that fits into a logic. And I have to say, that's initially what drew me to your work is there's a logic. You're not just saying, okay, this study said this, so I'm going to do this. It fits into a broader logic that comes from your training. So that's just a point of gratitude. And I hope it will frame in people's minds that yes, do what you feel, do what works for you, but try and frame it in a certain logic. Right. And because that's actually what gives you flexibility over time. Like, oh, you're traveling, you have to eat a little later. Okay, the next morning, maybe train fasted or vice versa.
Yeah, it's about the habit. Exactly. It's about the habit. And there are days when I just I can't train fasted, or there are days when I wake up and I have to eat. Exactly. Where you know, and there are days when nights when I'm eating later because of social obligations, and I don't freak out about it because it's about the habit.
I like the idea of one metabolic switch per day. You said you could get it from exercise. Yeah. And I thought, I can really imagine that in 5 years, a concept of health that hopefully everyone understands out there is that find a way to generate the metabolic switch once per day. Maybe you fast and exercise. Maybe you just exercise. Maybe you just fast because you can't exercise because people's schedules are constrained. But the notion of the metabolic switch is here's where it fits in exactly. The logic is you want the metabolic switch.
You do. And it's not just, there's other components to this metabolic switch that we haven't even discussed, which is when you're in that fasted state, when you're in the ketosis, that's also repair mode for your body, right? So there's the fed state, the grow, anabolic, and of course we're all obsessed with anabolic now because the associated with muscle growth, right? But there's also the repair and recovery state, right? And so you don't always want the growth on, right? You want to repair damage, and repairing damage can be damage to DNA. A lot of these genes are activated when you're in a nutrient deprived state, right? When you're in that metabolic switch. And autophagy, and that's another one that it's a buzzword now, but it is something that is activated. First of all, we have basal amount of autophagy going on at any point, right? That's happening.
You don't have to fast.
You don't have to fast, exactly.
Or be in a caloric deficit, which will also exacerbate it.
Right. Yeah. You do have fasted activated autophagy, and certain tissues are more sensitive, like the liver and the brain, actually. And so, we don't have a lot of human data on that in terms of fasting. Exercise also activates it. We don't have a lot of great quality human data, and that's for a lot of reasons. One is the tissues that are most responsive to fasting-induced autophagy are not blood cells. In fact, blood cells are pretty restricted in their response to fasted-induced autophagy, but that's the easiest cell to access if you're going to measure autophagy in humans, right? Muscle biopsies have been done. The muscle is also responsive to fasting-induced autophagy. It's responsive to exercise-induced autophagy. By the way, the exercise, again, it's increasing energy expenditure. So at the end of the day, you're getting into that sort of ketosis, right, state, the metabolic switch. So there are studies showing that there's a signal there, but for some people, it's not enough. Well, it's not enough. We don't really know, and you can't go off the animal data. And I think to some degree, it's going to be hard to go get a liver. I mean, maybe we'll have some tools soon that we can easily access a liver biopsy, and that'd be great for many reasons, right? Not just looking at autophagy. But I think that to some degree, you kind of just have to know that, okay, autophagy is happening right now in our cells. So we know that it's activated by fasting, by exercise, by these types of stress. And so why wouldn't it be increased somewhat? And when I say autophagy, I'm talking about clearing out gunk that's built up in your cell, throughout the day. We're talking about pieces of DNA, fragments of DNA. We're talking about protein aggregates that they're either properly, not properly folding, or they're not being degraded, right? All sorts of stuff, right? And it's important. This is a cleanup process. It's important. And so again, that's another part of the metabolic switch that I think it's important to think about, because we are really obsessed with anabolic. Is it anabolic? It's great. You definitely want to grow muscle, right? You do want to grow new brain cells and stuff too, but you also want to repair, and you want to have recovery. And that's another, it's like the yin and the yang, right? You kind of want both. So I think that's important to think about as well. And fasting, intermittent fasting, I like the daily metabolic switch. It may not be for everyone. Like I said, it's not. I do think that you can find other ways to get there, exercise being the big one. Some people do caloric restriction. Some people don't need to. Caloric restriction is something that helps if you're trying to lose weight, right? It helps if you're trying to lose visceral fat. It's one of the main ways you can do it. Intermittent fasting, caloric restriction, exercise, aerobic exercise that helps lose visceral fat. But I mean, obviously, we don't always want to be in a caloric deficit, but we always don't want to be constantly eating either. And that's why it comes down to, I think, the simple rule for people, like if they're going to do some sort of metabolic switch, some sort of intermittent fast, it would be like, okay, let's try to at least stop eating 3 hours before bed, because then you're at least going to be extending that fast somewhat by 3 hours, right? So I think and plus you're getting the cardiovascular benefits that are really seem to be important. And then not eating at night. So there's all these studies that have come out of Israel. I think is it Jacobitz and Freud? They're two researchers. I mean, Sachin Panda, I remember years ago, showed me one of the studies. It was like published in Science, showing that if you have the same exact meal, same calorie intake, same composition, macronutrient composition in the morning, the afternoon, in the evening, the insulin response is different. Like you're the most insulin sensitive early in the morning. As you start to go towards the evening, and particularly 3 hours before your natural bedtime, your melatonin levels naturally rise, right? And as you know, melatonin is important for the onset of sleep and preparing the body for sleep, but it's also preparing the other organs for rest and recovery, including the pancreas, which is making insulin. And so you're not making as much insulin when it's closer to your natural bedtime because of the melatonin levels that are rising. And so you don't want to be eating, particularly a carbohydrate-rich meal, but a meal, you're not going to be as insulin sensitive.
In the last 3 hours before sleep.
Yeah, when you're starting to get into that melatonin rising phase of, of your cycle.
Yeah, it's interesting. I think when people hear, okay, you're most insulin sensitive in the morning, that would be the time to eat your biggest meal. But then people say, wait, but then I'm trying to fast before, and I'm trying to exercise, and like, how do I do this? I think that's where, for them, the confusion comes in. And to me, it's very simple. Just because your insulin sensitivity is highest first thing in the morning doesn't mean you have to eat right away. I mean, it just means avoid eating too close to bedtime, right? Sometime during the day. And also if you exercise fasted or after a small snack. It was kind of interesting when Stacey Sims said, not everyone should exercise fasted. She said, especially a lot of women don't like to do that. She didn't say eat a meal. She said, like, have a scoop of whey protein with some, I think she said with like some almond milk in it. And you couldn't believe the response on the internet. It was like vindication, right? And I get it. It was like, it vindicated people's experience. Like, oh, thank you, thank you. And it told me something really important about the kind of sociology of what we do, which is when something validates people's experience, they love it. But it doesn't mean that the things that work for other people don't work. And I think that that's the part that gets lost. And so if a study shows that insulin sensitivity is highest in the morning, but you can only exercise first thing in the morning, what do? So you do the best you can.
Right.
Right. I think is what it comes down to. In fact, I meant to ask you earlier, and this is a good time to talk about this. You've described that if you are slightly sleep deprived, so not 4 hours per night or an all-nighter, but if you've only slept 5, or let's say you're getting an hour or two less than your normal ration of sleep, there's some pretty significant inflammation that occurs that's not good. But I've heard you cover that exercising can actually offset some of that inflammation. This answers an important and common question, which is, if I have to pick between sleep and exercise, what do I do?
Yeah.
And it sounds like if it's one night poor sleep, exercise.
Yes.
But you don't want to make it a habit. Do I have that right?
Yeah. I mean, so this data, a lot of it actually comes from, you can cause even acute insulin resistance after like a night of sleep deprivation, certainly after 2 to 3 nights of sleep deprivation. And, again, a lot of that's coming down to some of the things we've already talked about. And but exercise can help basically negate a lot of that. And I learned that firsthand through experience when I was wearing a continuous glucose monitor. And when I was a new parent, of course, you're not getting enough sleep. And so I learned it before I actually dove into the science about it. I learned about it through my own data, where I was, I wasn't exercising as much, and particularly in the first month, really, like, you're kind of in a cave as a new mom. You're not really exercising much at all.
Evolution wants the baby to survive.
You're recovering too. I mean, childbirth is it's a very traumatic process on your body. And so I noticed that my glucose response was like, it was like pre-diabetic, and I was like, what is going on? And that's when I started looking into the literature, and happened to be around the same time when I was then starting up at the time I was doing spin classes. And then it was very clear to me, it was like, I do these high intensity interval training classes even just twice a week. And it was like almost completely negating what I had seen previously of my fasting glucose being really high, and also my postprandial glucose being higher than usual. And so I looked into the studies, and there's now you can find many studies out there, and it really, I mean, obviously exercise is one of the best things you can do to improve insulin sensitivity and to also bring glucose into your cells, right? And so that's part of what you were talking about with, you're more insulin sensitive during the morning, least during the evening. And I also mentioned that, but guess what? There's levers you can pull that like change the equation. And exercise is a big one, right? If you're exercising, you're becoming more insulin sensitive, you're increasing more glucose transporters on your muscle that's causing glucose to go in easier, right? There's lots of ways around some of these rules that we hear about. But with the sleep loss, it really is, it's interesting because people, like, when they don't get sleep, the last thing they want to do is work out. And obviously, like, you don't want to do like the hardest thing, especially if you're really like sleep deprived a lot. But it really does help negate the inflammation and the insulin insensitivity that can happen after even just a single night of sleep. And there's studies out there showing that. And then there's also these longitudinal studies that have been done looking at, people. So obviously poor sleep is a problem, in the United States. I mean, a lot of people are sleeping fewer than 7 hours a night. And but there's studies out there that have looked at people that sleep either shorter, so fewer than 7 hours a night, or they're sleeping more than 10, right? So you don't want to be on either end of the spectrum. And usually, like, sleeping long, there's like other disease states associated with it, right? But so people that are sleeping, not getting enough sleep, they have a higher all-cause mortality than people that are getting at least 7 to 9 hours of sleep. And the same for like more than 10. They have a higher all-cause mortality than people getting between 7 and 9. But if people exercise, if they're meeting the physical activity guidelines right now, which is 75 minutes of vigorous intensity exercise and 150 minutes a week of moderate intensity exercise.
Right. Well, because the guidelines are helpful, but they're just guidelines because, I mean, doing the sort of workout that you're doing, working up to doubles and triples and singles on compound lifts, and then doing cardio, like getting your heart rate elevated, and then doing addition to that, and then your hiking. I mean, that it's just, I think the guidelines are a good jumping off place for people to think about.
Well, we can talk about that because there's a new study that kind of throws that on the head.
Yeah.
But the point is that if people were exercising within the guideline range, that they basically, if they weren't getting enough sleep, if they were getting fewer than 7 hours of sleep per night, that they basically had the same mortality rate as people that were getting enough sleep. So it's offsetting some of that unhealthy stuff, the insulin resistance, the inflammation that we know, can lead to diseases and early mortality.
So find the time to exercise, folks. Yeah. But of course, periods of time like after a new child or new job or particularly stressful time, I don't know any human being, I don't care how driven. There's probably Goggins and Cam Hanes being probably exceptions, and a few
outliers.
Others, I can ride out and a few others, but people who, everybody else seems to have periods of time where they need to just back off a bit. Mm-hmm. I know I certainly do. And I feel like I'm doing pretty well for myself despite, and I think that it's important that people not hold themselves to a standard that is going to make them sick or injured or miserable beyond. Yeah, you also want to continue to enjoy health promoting activities, right?
Right. I mean, you got to say, like, what's your goal? Like, your goal is to be healthy, to be happy. If you're taking it to this extreme where you're trying to just go to the extreme, like go hard, go home, and you're sacrificing your happiness too. I mean, that's a problem, right? Because that's part of the equation. Happiness is part of that healthy equation.
Health is a daily and lifelong thing, but sometimes it means taking a day off. I think that's what people don't say. And I think it's in a time when perhaps a lot of people aren't exercising enough. So promoting the no days off thing can be helpful. But for those that are already forward center of mass, coming off the accelerator can be really useful.
Well, I also want to just mention, because, we talked about I work out a lot and I'm sort of addicted to it, but like not everyone has the time and motivation to go spend an hour block of time working out. And this is where I think the people can sigh a sigh of relief, because there's now so much emerging data that have been coming out over the last decade on these short bursts of physical activity that add up. They add up, and people aren't really thinking about them, counting towards adding up to their physical activity, requirements for the week. And so there's a lot of studies now. There's on something called vigorous intermittent lifestyle physical activity, VILPA studies. Have you heard of those?
Are these the exercise snacks?
They're unstructured. Mm-hmm. They're unstructured, and not everyone likes the word exercise snacks. I mean, I kind of like it, but the unstructured exercise, they're the moments in your life where you're taking advantage of everyday situations to get your heart rate up, to move. And so that could be, I'm playing with my new puppy and I'm sprinting around with my new puppy. Mm-hmm. I'm, chasing my grandkid around. I'm playing tag, or my child. I'm sprinting up the stairs to get to my office. I'm running to catch the bus. I'm moving, right? And so researchers, and there have been several studies on this now, researchers use accelerometers rather than just relying on these questionnaires, which are, as you know, extremely unreliable. I mean, it's very hard for people to remember how much exercise. You sitting here asking me about my exercise. I mean, there's always so much, that you can be accurate when you're trying to recall that. So these accelerometers are worn on people's wrists, and they're measuring like fast movement, the movement, right? And so thousands and thousands, like hundreds of thousands of participants. There's lots of data now showing that people that are doing these like short bursts at least a minute long, but up to 3 minutes, right? Where they're moving. I'm saying they're getting their heart rate. They're actually not measuring the heart rate in these days. They're moving faster with intent, right? They're jogging, or they're not. Of course, there's the cases where they're actually exercising, but the short bursts of it, they're doing the things that I just mentioned, and it's having outsized effects on health outcomes. So, for example, individuals that do on the high end, so they're doing 3 minutes of this short burst of an unstructured type of exercise snack, and they do it 3 times a day. So it's a total of 9 minutes a day. Okay, this type of activity, and it's considered more vigorous because of the intent to move, right? That's more vigorous, even though they're not measuring heart rate. That's associated with a 40% reduction in all-cause mortality, 40% reduction in cancer-related mortality, a 50% reduction in cardiovascular-related mortality.
Wow.
9 minutes a day. And this is even in people that don't identify as exercisers. So they're not the kind of people like you and I that go and intentionally set out time to go to the gym. They're people that they're doing those things, right? They're playing with their grandkids or their kids or their puppies or whatever. And so these moments, they add up. And I'm citing one study, but it was a dose-dependent effect, even doing 3 minutes a day. There's a study in women showing 3.5 minutes a day. I mean, they were having pretty profound benefits on all-cause mortality and cancer-related mortality as well. And multiple studies now have shown this. I mean, this is like one study after another after another. I mean, it is undeniable that these short moments of, getting physically active do add up. And structured exercise snacks can be part of that. Like maybe you don't have a puppy, maybe you don't have a kid yet, maybe you work from home and you're not taking this, maybe your situation is different than what I described, but you can take these moments to do exercise snacks. And that can be a minute long, and it can be like there's studies showing that two studies, and I'll talk about one, showing that getting up and doing 10 body weight squats every 45 minutes over a 7.5-hour work day is better at regulating blood glucose levels than a 30-minute walk, right? So you get up and you do 10 body weight squats. Pretty easy. I mean, it's also very good to break up that sedentary time. Mm-hmm. So being sedentary means like you're not moving. That also is an independent risk factor, even if you do exercise, for things like cancer being a big one. Although I would say if you're doing a lot of exercise, you're doing pretty good. But I just like to mention that as well. I would say being sedentary is a disease, actually. That's something, I mean, people aren't thinking about it, but
even in the absence of what Lane Norton calls energy toxicity, like even if somebody is at maintenance or below maintenance calories, if they're sedentary, that's problematic.
We do have data, for one, measuring cardiorespiratory fitness, which is a marker of cardiovascular health, being physically fit, right? Obviously, the gold standard of that would be measuring VO2 max, your maximal oxygen uptake during maximal exercise. A lot of studies do not actually directly measure VO2 max. They'll do, maybe a submaximal treadmill test, or they'll estimate it, right? There's a calculation out there you can do, kind of if you wear like an Apple Watch or some sort of fitness tracker, what they do is, it's looking at the distance that you run and the amount of time it takes, right? So like a 12-minute run would be an example. People do that. You run as fast as you can and maintain that pace for 12 minutes. So you're not going all out, obviously.
You see how far you can go.
Yeah. And there's a calculation out there that's done to kind of estimate your VO2 max. And so some studies a lot of studies are actually doing sort of an estimation of cardiorespiratory fitness. So cardiorespiratory fitness is really important, I think, for marking your health and longevity. And, if you have a low cardiorespiratory fitness, most of the times you are not physically active, right? And there are studies showing that if you don't have any diagnosable diseases, so you're not insulin resistant, you don't have cardiovascular disease, you don't have cancer, all that stuff, right? You're not obese, but you have a low cardiorespiratory fitness, it is as bad or worse in terms of your all-cause mortality, your predicting mortality, than having cardiovascular disease or smoking or having hypertension or these things that we know that are really bad for health, right? So being sedentary, as I'm saying, it's a low cardiorespiratory fitness. I guess it's not exactly correct. It's a little bit, I'm stretching it a little bit. But cardiorespiratory fitness is a marker of, I would say, fitness. And so that's why I think being sedentary is a disease. And people with a low cardiorespiratory fitness, I mean, if you go anywhere above that, from low to like low normal, that's associated with a 2-year increase in life expectancy. If you go from low to high normal, that's like almost a 3-year increase in life expectancy. And if you go up to high, then you're talking about a 5-year increase in life expectancy compared to where you were at with low. But again, I'm not talking about VO2 max, I'm talking about cardiorespiratory fitness. And it's really important. Here's another reason why I think that it's really bad. So these studies were done, by the way, cardiorespiratory fitness is improved by aerobic exercise in general. That's great. And then, if you add in high intensity interval training in their mix, that also really helps, because there are some people that don't respond necessarily to just doing
slow,
cardiovascular.
steady state.
Yeah, about 40% of people don't respond. So mixing in the high intensity is good. If you're physically active and doing that, that's great. If you're doing these short bursts of physical activity, also good, because it's a little bit of a high intensity, exercise, right? A minute running around chasing your grandkid or your puppy or your child. That's a hit
Taking the
section.
stairs is amazing. I was traveling with my team.
Sprinting up the stairs.
Sprinting up the stairs, or if you're carrying a lot of luggage in the airport, like going up the stairs or down the stairs.
Right.
It's wild when you go to the airport. I like to notice this. Nobody takes the stairs.
Yeah.
Down or up,
Yeah,
like the
'cause the
escalators are
luggage,
there.
the luggage.
And I'm always like, oh, there's a great opportunity to get some extra steps and some extra work. But I realize that's me. But it's striking. And if you're in DC ever, they have these long stairwells that go up from the public transport, and that's a workout,
Carrying your luggage.
And I'm always like, oh, free workout.
Yeah,
like,
yeah.
like get it in my day. I mean, it sucks to arrive a little bit more sweaty than you would otherwise, but I just think if this were an experiment and we were looking at mice and we were videotaping from above, I always think to myself, like, which mouse am I going to be? All the mice are going up the automatic elevator. It makes sense. And then why they would want to do that. But these opportunities for exercise are clearly there. I feel like this is also, I would be remiss if I didn't do a quick shout out to Steve Magnus. Do you ever see his content?
I've interacted with him, yeah.
Yeah, I've never met him, but people should.
On Twitter, I've interacted with him on X.
Yeah, people should, I think, give him a follow. He's a very accomplished runner in his past, a running coach, I believe, as well, and a scientist. And I think has the best take on sort of measuring VO2 max. It's kind of interesting. He has a theory, which I think is strongly backed, that most measures of VO2 max are not measures of VO2 max at all. But one of the best measures of cardiorespiratory fitness is how fast can you run a mile? And he says people are generally surprised how easy the easy stuff should feel and how hard the hard stuff should feel. So I just want to credit Steve for saying that. So I try and keep that in mind around my cardio and do I do less of what you do, I confess. Some high intensity interval training, Tabata type stuff, and then a lot of walks, a lot of hikes.
Yeah.
And I haven't formally measured my VO2 max in a while, but I think he just nails it with that, because I think people think the 30-minute jog on the treadmill where you get sweaty and you're like, that's accomplishing what you want. But actually there's a much easier path to better health, which is what you do and more or less what Steve is describing as well. Yeah. Does that square with your experience?
Yeah, I think so. I mean, I do mix in quite a bit of probably more high intensity interval training, but I don't feel like, if I felt like it was like, if I didn't feel good, I would toggle down the pedal, right? I wouldn't keep going on it. So
Right.
I think you have to, again, just listen to your body. You don't want to overdo things. And there are people out there that are really like endurance athletes that are, like, that's not me. I'm a committed exerciser. I'm not necessarily an athlete. But yeah, so there's different, I think, levels here. And Steve is obviously athlete.
Anyway, I've learned from him around this topic.
Yeah.
It's been helpful.
I'd like to take a quick break and acknowledge one of our sponsors, Function. Last year, I became a Function member after searching for the most comprehensive approach to lab testing. Function provides over 100 advanced lab tests that give you a key snapshot of your entire bodily health. This snapshot offers you with insights on your heart health, hormone health, immune functioning, nutrient levels, and much more. They've also recently added tests for toxins such as BPA exposure from harmful plastics and tests for PFASs or forever chemicals. Function not only provides testing of over 100 biomarkers key to your physical and mental health, but it also analyzes these results and provides insights from top doctors who are expert in the relevant areas. For example, in one of my first tests with Function, I learned that I had elevated levels of mercury in my blood. Function not only helped me detect that, but offered insights into how best to reduce my mercury levels, which included limiting my tuna consumption. I'd been eating a lot of tuna, while also making an effort to eat more leafy greens and supplementing with NAC, N-acetylcysteine, both of which can support glutathione production and detoxification. And I should say, by taking a second Function test, that approach worked. Comprehensive blood testing is vitally important. There's so many things related to your mental and physical health that can only be detected in a blood test. The problem is blood testing has always been very expensive and complicated. In contrast, I've been super impressed by Function's simplicity and at the level of cost. It is very affordable. As a consequence, I decided to join their scientific advisory board, and I'm thrilled that they're sponsoring the podcast. If you'd like to try Function, you can go to functionhealth.com/Huberman. Function currently has a wait list of over 250,000 people, but they're offering early access to Huberman podcast listeners. Again, that's functionhealth.com/Huberman to get early access to Function.
I want to ask you about creatine.
Yeah.
I'm 50. I started taking weight training and running when I was like 16, maybe. Yeah. And I started taking creatine because back then I was skinny. I wanted to put on muscle. I think creatine was sort of first discussed or released back then when I was maybe 18 or something like that. 18, 19. So I've been taking it a long, long time.
Yeah.
5 to 10 grams. But the original protocol, which nobody does anymore, but I confess I still do it because I enjoy it, was to take 5 grams 3 to 5 times per day. There was this loading phase. And you would mix it with a little bit of grape juice because the idea was you were supposed to spike your insulin and then you get more into the muscles. And then you had a maintenance dose, which was 5 grams per day. And the idea back then was that you needed to do a washout every 20 weeks or so, where you just stop taking it, you urinate out a bunch of water, and then you reload. And I confess, I've continued to do this minus the grape juice, but occasionally I'll do the grape juice thing. I don't think there's any real merit to the loading phase, maintenance phase idea. But back then and still now, I feel like creatine has made me feel great, stronger. I wasn't aware of the cognitive benefits.
They weren't being studied back then.
They weren't being studied back then. But what are your thoughts on why creatine suddenly has become this like banner supplement? It's like supplement of the year. We should start a supplement of the year thing, right? For a while, I think vitamin D and melatonin came first. And we'll have to figure out what years those were. Then I feel like creatine got supplement of the year for 2026 unless something else comes along. So creatine, supplement of the year, 2026, even though it's been around for a long, long time. What do you think happened?
Well, so first I want to talk about your loading phase. And that was really for the studies that were being done, right? Because if you're taking 5 grams a day of creatine, it takes about 3 to 4 weeks for your muscle creatine stores to become saturated. And researchers aren't going to do a study where they wait that long. So the loading phase really was
So that's what inspired it.
Yeah, it's in this isolated bubble of in the experimental protocol, but like in the real world, you have 3 weeks. Or if you're like an athlete and you hadn't, taken the creatine, you don't have your creatine stores up and you have to rapidly.
Got it. I was just amazed at how quickly it worked. I might be a hyper responder, but I legitimately I realized some of it was water or most of it was water, but somewhere between probably 4 and 8 pounds of water in the muscle mass. I don't want to call it lean mass because it's water in the muscle. But I was like, oh my goodness, this is crazy, And then people thought maybe it was a steroid. It's not a steroid. Maybe it's bad for your kidneys. Turns out it's safe for your kidneys and most everyone. Pretty remarkable molecule.
Yeah, I mean, obviously creatine is stored as creatine phosphate in our cells. We make, to some degree, between 1 to 3 grams of creatine a day. Our liver, our brain also makes it. It's used to make energy. And so your muscles, if you're working out, you're really consuming a lot of energy, right? It's very energetically demanding. So having the creatine stores higher in your muscle is beneficial because, one, you're going to be able to increase your training volume, right? So it's not like creatine is anabolic in the sense that protein or amino acids are, right? It's not like directly affecting muscle protein synthesis. It's just helping you train more, getting more reps in, whatever it is, your training volume's going up. And because your training volume's going up, then you're obviously putting more stress on your muscles, which is going to lead to increased muscle protein synthesis. And, obviously there's water probably as well. That said, you asked me, what happened. So I got interested in creatine back in when I started basically weight training. Obviously I'd heard about it forever, never took it. And as I started to get into resistance training, I was like, I better start taking this. I'm like in this world now, and started doing some research on taking it. So I was taking the 5 grams a day because that's really what most of the studies show. Creatine monohydrate, that's the most well-researched form of creatine. And I was taking 5 grams a day because I was interested in improving my training volume and getting the benefits of it, right? And then I had Darren Kando on the podcast. That was in 2024, I think it was. And once I had started getting into the creatine research, the brain stuff has been coming out over the past, few years. And that's, for me, become very interesting. I remember the first time I heard about it years ago, it was like, oh, it's helping improve cognitive function in older people.
Yeah, the phosphocreatine system seems to be somewhat biased towards forebrain structures. Obviously it's in lots of brain areas, but that there might be a heavier reliance on it for brain areas that are associated with strategic planning and working memory. And if you were to sort of just map the sort of density of usage of the phosphocreatine system, you'd see a frontal bias for sure.
Okay.
Yeah.
Well, anyways, that's kind of where my interest in kind of diving deeper. Anything that's helping the brain is interesting to me, as I know it's to you as well. And so I learned a lot from this podcast I did with Darren Kando. He, researches creatine and collaborates with a lot of different researchers that are doing, research on the brain and muscle and, lots of the bone. It turns out it's beneficial for the bone as well. But the brain, it's interesting that we also make creatine in the brain, but it's not like, so it's kind of like the muscle, right? You're not just if you take creatine and you don't work out, you're not gonna get any increase in lean mass, right? It's not gonna do much of anything because you're not putting in the work. I think the same goes with the brain as well, where it's like researchers started to find out that, well, you can't just take creatine and it's going to enhance cognitive function. It's in the background of stressing the brain, right? You're stressing your muscles by workout. Same goes for the brain. It's like in these situations of stress, whether that's sleep deprivation, whether it's, a traumatic brain injury. I mean, I would argue, there's a lot of psychological stress, depression, constantly using your brain, like you and I right now in this conversation, we're learning, we're thinking. I mean, it is stressful on the brain, right? So, I mean, I'm obviously speculating here and I'm extrapolating, right? I'm not saying that there's studies showing that, but it does seem as though that's when creatine seems to shine in the brain. And you might go, well, your brain makes it. And it's true. Your brain does make, again, it's like, I think between 1 to 3 grams or something. I'm not exactly sure how much, but it makes its own creatine. And it's kind of resistant to taking up the creatine that you're supplementing with, particularly because, for one, the muscle is very greedy. So when you're getting to that 5 gram range, muscles are really consuming, if you're working out in particular, right? Your muscles are kind of consuming that because they're very greedy for it, right? And there have now been, I think, a handful of studies showing that when you start to get above that, there was a study out of Germany showing this, and it's a small study. This needs to be replicated. Like, this is all new, emerging data. But that study showed that once you start to get to, 10 grams, then if you look by MRI, you can start to see that creatine levels are increasing in certain brain regions and perhaps in the brain regions that you were talking about. And they're going higher than what you would get from just your brain normally making its own creatine. So the 10 grams of creatine a day, which is now what my baseline is based off of that. But there's studies now showing that if you are in this sort of stressed state, your brain is stressed, like for sleep deprivation, for example, you're sleep deprived for 21 hours and your brain's not working very good after not sleeping for 21 hours, right? I mean, that's obviously when I travel internationally, I'd never really sleep good on an international flight. And so I'm like if you were to come find me after that flight, I'd be like not working very good, right? Cognitively.
You and everybody else.
Right.
Yeah.
Well, some people can sleep great on a plane, but I'm not one of those people. So there have now been at least one study showing that if you give someone, it's like something like 0.35 grams per kilogram body weight of creatine, which comes out to a lot. I mean, it's like 20, 25, it depends on your body weight, right? Like 20, 25 grams, perhaps even more. I mean,
I'm 100 kilograms.
Yeah,
That's
so you would be
creatine.
a lot.
Yeah.
So for me, it's more like 20, 25 grams, right? But if you give individuals that high dose in that, sleep deprived state, that they're cognitively not only performing normal, but they're performing better than their baseline. And that, of course, generated a lot of interest. There have been studies coming out since then showing that, okay, if you give older adults with mild cognitive impairment, perhaps mild, early stage Alzheimer's disease, again, 20 grams, you're giving them in the 20 gram range of creatine, it's improving their cognitive function. Why is that? Well, creatine is important to make energy. And when your brain cells are stressed out, right? I mean, like energetic demand goes up. And if you have more creatine, it's going to make things easier. There's also some inflammation that's being generated in that stress state. And it seems as though creatine is also having both an indirect and direct effect on inflammatory processes as well. This is all early data. Like more needs to be done. But I think there's enough safety data out there now where it's like, well, it's really not harmful to take 10 grams a day. I take 10 grams a day every day.
You spread it out?
I do it in 2 doses. I mean, some people are very sensitive to a 10 gram dose where they might get a GI irritation effect.
It can give some people diarrhea.
Exactly. Yeah. So the very scientific way of putting it. Yeah. But I mean, so I do spread it out and I don't take it at night. I like to take mine in the morning. And I don't know, Andrew, this might be a placebo. I feel like I'm constantly my brain is under a lot of stress. I'm constantly learning. I'm reading papers. And like I said, I'm extrapolating here. This isn't sleep deprivation. That's obviously a much more extreme type of stress. But I have noticed that taking my 10 grams, going from 5 to 10, really does seem to affect my brain functioning like later in the day, where I seem to keep going better, where I'm not getting as tired. And it could be placebo, which is fine. Like I said, I am fine with placebo effects as long as what I'm ingesting is not actually bad for you. Placebo is fine with me. But it is working for me. When I travel, when I'm going to the East Coast, I mean, I'm on the West Coast, so when I go anywhere and I have to give a talk early in the morning and I never sleep good in a hotel, I'm always sleep deprived. I mean, I don't know that a time that I haven't been traveling and I'm going to start traveling with my pill like you do because that's brilliant, because that's like one of my problems. But there's many problems in hotel rooms that lead to me not sleeping as good, right? So I take 20, sometimes 25 grams of creatine in those situations, and it's like, it's not all the time, but it seems to help me again. And like I said, I'm okay with placebo, which is fine, but we do have some evidence that it might. And I think this is kind of where people are already interested in creatine. And so when you start to go, well, maybe it's going to be beneficial for the brain. If it's going to improve cognitive function, that's really something that people are interested in.
Right.
Now, again, I don't know that it's like if you're just some young, healthy person that gets you're sleeping well, you're exercising, everything's great. And I mostly sleep well and exercise great. I'm extrapolating here, but Alzheimer's disease on the extreme end, TBI also on the extreme end. That's real-time aging, right? And there's some evidence that may be helpful for that as well. There's been some studies with children looking at creatine supplementation after a TBI, and it seems to help with their recovery. I am probably experiencing brain aging. So I'm just kind of...
I'm going to interrupt there. I don't think so. I'm not trying to just be complimentary. I paid close attention to the data, and it seems like in certain fields like math and physics, people tend to peak with their contributions early. There's a reason why the Fields Medal is only given to people, I think it's 40 or younger. My dad's a physicist, so he can check me on this one. But biologists, at least the ones I know that took good care of themselves, they're known to make great discoveries, be cognitively sharp, intellectually strong, well into their 70s and 80s. I mean, Torsten Wiesel, who co-recipient of the Nobel Prize for brain plasticity and vision, he's still alive, and I think he still runs. He's in his late 90s, and he paints, and he's sharp. So I made it a point to only interrupt here. People can check the data on the previous portions of the podcast, and just say, I actually think that cognitively, I'm using biologists as an example, it's possible in aspects of life where you're building a base of data to pull from, which is what biology really is. It's just an example here, that to get cognitively stronger and stronger with age.
Right.
There's a theory, but I see you as that. And I'm not just saying it to be complimentary, although it is a compliment. It seems like you're picking up steam. You're thinking about things. You're not forgetting things from way back when. You're building on the concepts and knowledge from way back when. So I find it reassuring that biologists in particular seem to have this, up and to the right trajectory for cognition.
It's interesting. My late mentor, Dr. Bruce Ames, was every bit of that. I mean, he passed away a little over a year ago when he's 96, but he claims some of his best work was done, in his late 80s.
Right. You don't see that in math or physics.
Yeah. So that's interesting. And I don't know exactly the difference. I mean, I don't know how much learning goes into math and physics as you're like, I just don't know. But with biology, and I mean, we're constantly learning new things and reading new papers, and then I think even just the novelty of learning new things, I mean, that's brain-derived neurotrophic factor, right? Like that's like you're increasing synaptic connections and neuroplasticity, and you're keeping your brain younger in that way too, right? So I think the learning process is super important, whether it's biology or whatever you're passionate about, right? Like you learn new languages, whatever. Like the learning process itself is something that is so important for brain aging as well. And yeah, so I would agree with you that, but brain aging in general, yeah, I'm obviously chronologically aging, and there is some degree of aging going on in my brain. But so that's I think where the creatine crazes come from is the interest in, and I've definitely played a role in some of this, by talking about my experience and being super interested in it, because it's like it's felt good for me, and I've noticed this experience, and this is completely anecdata again. But in addition with the small studies, and they are small, and I don't know if you've looked at them, but they're subject
numbers are
they're small, and you can poke holes in them, and you would be completely okay poking holes because they're small sample sizes. But it is kind of a consistent trend line where we're seeing more studies come out and show the same thing, and it's like, okay, to a certain point, maybe there's something here. I think that more research is going to come out on it. And I feel great doing it. So, I mean, and even to the point where if I don't have my 10 grams and it's only 5, I'll notice.
Oh, yeah?
Yeah. But again, it could be that, placebo, nocebo thing where who knows? Who knows? But, let's just say it is real. For me, I gotta have my 10 grams of creatine for my brain. Who knows? I may in 5 years be like, I was wrong. We'll see new data come out. But I don't think so. I think we're going to have, I think this is like the next, a lot of people doing creatine research. It's the new thing. They're really, because there's been a lot of work on exercise physiology and,
the safety
volume. Data
are there. So it's not like they have to get a lot of, human subjects clearance.
The safety data is there. The safety data is, I mean, it's the most well-studied, one of the most well-studied supplements out there. Like you said, I mean, you were taking it when you were 18, and it was studied back then. Yeah, and it's just been studied for all the years that you've been taking it. So, I mean, if it was unsafe, we really would know. And again, I don't want to get into all the data on the safety, but I think that it's pretty solid that it's now. Of course, if you're going to go mainline 50 grams a day, I mean, I don't know, that's a little much.
Someone on the internet
there's
will
always,
do it.
Yeah, there's
people
always the extreme.
What are they, dry scoop? I mean, people have died dry scooping energy drinks. I mean, there's always a moron or two out there that are going to take things to the extreme and harm themselves doing something that no one else is dumb enough to do. But I think we look at the center of mass for things. As we're talking about creatine, I want to talk about some other supplements. But it occurs to me that if there's some data, ideally from animal studies and humans, and something is safe, I think the question nowadays, because of how broadly health and supplement and other kinds of information goes in the world. I think the question that everyone should ask themselves is, okay, do I want to be in the experimental or the control group? That's how I think about it. So like if there's a study about creatine or some new molecule, I'm going to ask you about magnesium in a moment, right? I look at the safety margins on magnesium. Okay, I'm comfortable with those safety margins. So that should always be question number one. And then it's, do I want to be in the experimental or the control group? And I think that these days people who are against supplements or against something, they'll say, well, the effect isn't nearly as big as you get from exercise. Totally, absolutely. But that's not really what we're talking about. People love this in the cannabis and alcohol thing. Whenever I make a point about alcohol or cannabis, they'll say, well, alcohol is worse. I'm like, yeah, and? I mean, these are two separate entities. So I think that people should just ask themselves, are you comfortable with the safety margins? And do you want to be in the experimental or the control group? And then, of course, there's can I afford to be in the experimental group if I do something? But those are really the only questions. There's no one saying that creatine's better than anything else or worse than anything else.
Right.
But somehow the messaging gets all messed up. And then all these news articles get generated about what creatine is and it isn't. And I find it like kind of frustrating because that's the issue is not whether or not creatine is better than exercise and good sleep. The question is, do you want to be in the experimental or the control group, and can you afford to be in the experimental group?
Right. I like that. I like that framework, especially if it's like, well, we know it's safe. Okay, so I can potentially be in the experimental group, because that's question number one. You have to have that answer first, right? At least in my book. But yeah, I mean, there's flaws with all sorts of studies, and creatine studies included, right? And people make all sorts of claims about it, and you got to tone it down a little bit. I mean, it's not like the best performance enhancer ever,
right?
But it seems pretty good at improving exercise volume, recovery as well. I mean, that's like also something that's been shown, and then helping with the stressed out brain.
On the basis of our last conversation some years ago on this podcast, I started taking Lovaza, which is as you know, a prescription omega-3, so very high concentration omega-3, because I was getting it from standard sources, and I thought, well, I'm hitting 50 and up my omega-3, and I want clean omega-3. I don't want it contaminated with mercury and other things. So I'll take omega-3s in the form of Lovaza. It's available generic form now, so it's pretty inexpensive. And I have to say my blood profiles were pretty good, but they improved pretty dramatically when I started taking Lovaza. So I'm grateful to you for encouraging the omega-3, take the omega-3 path.
Have you ever had an omega-3 index test done?
No.
To measure the...
Oh, if it's on the function test, and then it would be...
I think it is.
Then it's in normal range. I know it wasn't flagged, but I don't recall what the level was.
Yeah. You want to be in the high index, not the low, right?
Yes.
Well, obviously, if you're taking it, you're not going to be in the low.
Yeah.
Usually it's around 2 grams a day to get you from low to high. And I do think that's one of the low-hanging fruits in terms of like something powerful and having an outsized effect on your health that people can do that's not that much effort. It's not like exercise is effort.
Or eating salmon. I don't like fish.
No, yeah. And a lot of people don't like fish. And also there's now microplastic contamination in our seafood sources. There's the heavy metals, PCBs, contaminants. I mean, I still eat salmon, but it's not like it used to be. So there are other cleaner ways to get your omega-3 levels higher, and omega-3 is very important for cardiovascular. It's one of the most important, I would say the most powerful naturally occurring dietary compounds for suppressing inflammation and resolving inflammation would be a better way of putting it, right? I mean, and that's, again, at the core of aging. And if you look at any sort of measure of aging, whether it's even these epigenetic aging clocks, they're very sensitive to inflammation. And that's why there's so many studies coming out now showing omega-3 can slow this, biological aging as measured by these epigenetic aging clocks. And that's, I think, even in randomized controlled trials showing this, that it's doing that. And that leads to functional outcomes as well. So like even if you're only slowing the clock, let's say by 3 months, you're still having outcomes like where, for example, 3 months slowing the epigenetic aging clock by omega-3 only is going to get you 16% lower pre-frailty, or if you add in vitamin D and resistance training, because the study showed a synergy between the three, then you're talking about like lowering the chance of invasive cancer by 66%, even though you're only getting
66.
Yeah, even though you're
So
only
vitamin
getting,
D, resistance training,
and omega-3.
And omega-3.
Yeah, and this was the trial was actually out of Switzerland, I believed, and it looked at omega-3, vitamin D alone, or resistance training alone. And the only thing that actually slowed the aging of the clocks was omega-3. Now, I'll say that with a caveat, okay? The baseline exercise in this Switzerland group, 88% of these people were physically active, like doing exercise. So adding, 30 minutes 3 times a week of resistance training on top of that didn't slow the clock more. And I wouldn't expect it to be honest, when you're already physically active and that's your baseline. Clearly, they weren't eating enough omega-3 because that did slow the epigenetic aging clock. Other studies have shown if you're vitamin D deficient, severely vitamin D deficient, like African Americans, for example, who are obese or overweight, if they add in vitamin D and supplement with 4,000 IUs a day for 6 weeks, they can actually slow their reverse their epigenetic aging as well. So I think it's all like where you're starting from. But the point is that the omega-3 alone did slow the aging of these clocks. And you add in the resistance training and vitamin D, those alone didn't do it. But when you add it with the omega-3, there was synergy. So it kept going down. And when the three combined, it slowed the epigenetic aging by like 3.8 months. But that translated to like 66% less likely to get invasive cancer. And then the pre-frailty was the omega-3 alone. And there was another marker, I can't remember. I covered this in a newsletter a while back. But this isn't the first study to show this with omega-3. Omega-3s are really, I went on this tangent. I'm sorry, Andrew. You got me on one of my favorite topics.
I'm excited because I take Lavazza, I take vitamin D, D3.
Yeah.
I take a lot. I take 5,000 to 8,000 IUs per day, and I get sunlight. People actually ask me, this is just a quick window into the messaging around sunlight. Some people will say, if I take vitamin D, do I still need sunlight? And, a big part of my messaging is trying to tell people sunlight does a bunch of other things. But I take vitamin D at that level. I take the Lavazza, and of course I resistance train. And the Lavazza move, and actually increasing the vitamin D was on the basis of, yes, blood work, but also our prior conversation. I feel much better.
Yeah.
Much better when
I take about 5,000 IUs a day as well. And I do get sunlight. And I agree with you, sunlight's important and vitamin D production is not the only thing that sunlight is doing, obviously. You've talked in great depth about that.
I'm going to go into the grave. I actually want a little window over my grave. It'll be a little morbid so I can get morning sunlight. I'm just kidding, folks. When I'm in the ground, I'm in the ground. No, I think the omega-3 literature has been greatly assisted by your messaging around it because it got pretty confusing out there for a while. There was the usual pushback that comes after Supplement of the Year is released. It's a joke, folks. Is oh no, it's actually bad for us. There's always a few of those. And then we eventually arrive at sanity again, and you go, no, the bulk of studies point in the direction of this being healthy.
Right, randomized controlled trials showing it improves cardiovascular health, lowers the incidence of, cardiovascular events, including heart attacks and strokes, right? These are the gold standard. We've got the observational data. We have now, looking at the molecular events, epigenetic aging, we know that it's really good at resolving inflammation because you want your immune system to be active, but you don't want it to be overactive. You want it to be active and then turn off, right? And so the omega-3 fatty acids like DHA and EPA, which are in Lavazza, are what when they're metabolized, they're forming these molecules, resolvins, protectants. These things are resolving inflammation. And so I think that it's one of the easiest ways that you can increase your anti-inflammatory response, and exercise obviously being another very powerful one. But the omega-3s, it's always easier to take a supplement. And so I have my parents taking it, anyone that I care about, it's easy, done. Take your 2 grams a day. I say 2 grams a day because, Lavazza is prescribed at 4 grams a day. So 2 grams is pretty on the conservative side, and that's really what's been shown by Dr. Bill Harris and some of his colleagues that you can take someone from a low omega-3 index of 4% up to a high omega-3 index of 8% by supplementing with about 2 grams a day. So, and by the way, there's all sorts of data on that front with the omega-3 index, and I think we talked about this last time, but 5-year increased life expectancy if you're on the high end. You're talking about 90% reduction in sudden cardiac death.
Brain weight in children if pregnant women are taking.
Yeah. I mean, it's important throughout the lifespan. It's, from in utero development throughout childhood all the way through adult life and into old age. These omega-3 fatty acids I'm talking about the resolving of inflammation, but they're also very important they're incorporated into our cell membranes, DHA, and to some degree EPA. And that has a very important role in the fluidity of our cell membranes. And this is important if you think about our endothelial cells lining our vascular system, our arteries, you want them to be fluid and more flexible, right? That's very important for being able to respond to a stressful situation. In fact, the stiffening of our heart with age, the collagen that surrounds our pericardium, or that's surrounding our heart, our pericardium and our myocardium, like that's increases the risk of a heart attack, a cardiovascular event. You want your cells to be more flexible. So that's what, these omega-3s are also doing. And that's why they're also really important for cardiovascular health in addition. And in the brain as well. I mean, all of our transporters, all of our receptors, right? They're embedded in the cell membrane. And the fluidity of that membrane is important for the structure and function of these things. And that's why omega-3 affects dopamine, serotonin, right? It's why it's affecting, it's not the only reason. Inflammation is also, but part of the reason is because it's changing the way our cell is structurally composed. And if you think about trans fats, they do the opposite, right? They stiffen the cell membranes. And that's why it's the worst thing you could do for your one of the worst things that you could do for your cardiovascular health is eat a bunch of trans fats. Smoking is another one. Smoking's terrible for your cardiovascular health.
Do people still eat trans fats?
No.
I feel like trans fats got executed in when was it that trans fats got executed?
When they all became, I think it was 2018. I mean, when they're all
they were sentenced to death. Yeah.
No, it's the point is that we all know trans fats are bad for our heart, but we don't think about why. And they stiffen. I mean, the researchers doing it know. I mean, it's stiffening your endothelial cells.
Well, donuts, right? As in, if you go get a donut, isn't a donut have a bunch of
I don't know how much
fried foods?
There's probably some amount of trans fat that's below the threshold of being.
It's the only bad food I miss.
Yeah.
The late night donut.
I had so much margarine as a kid. My mom used to buy it by the tub. I remember it's this. She used to go to Costco and get this big yellow tub of margarine.
I remember those tubs.
Everything was cooked in it. And I mean, it was on our toast. And
this was a battle in my home. Actually, I'm gonna resurrect some family battles of the butter margarine battle was a battle.
Yeah.
Butter won.
Yeah, it doesn't taste the same. But that was the craze. Yeah. It was the loaf. The fat was bad and butter was bad and margarine was good. And it turns out, no, trans fats are really bad. But the point I was trying to make was to help contrast for people to understand. Sometimes when I talk cell fluidity, people are like, what?
No, it's good that people, I think it's very important that people understand some of the cellular and molecular underpinnings of protocols, because I strongly believe that understanding mechanism, even just a little bit, or striving to understand it, embeds the information for people, makes it more likely that they'll do the behaviors, and gives them a logic to work from when they have to make choices, because life isn't perfect.
Right.
I know that to be certain.
I completely agree with you. It's certainly for me, but that is also my hope. I think that if people kind of understand somewhat of the why, it's motivating to try to adopt the healthy habit. But also, I think it helps them remember why it's important, right?
Yeah, and it's how the brain learns. The secret is context. The way to remember something is context. People always say it's story. No, it's context. And anyway, you and I know that to be true from our background. If I may, I'd like to ask about magnesium. I'm very bullish on magnesium, in particular magnesium 3 and 8 before sleep. For sleep, I take AGZ because I help them build it. It just has a bunch of things like magnesium 3 and 8 and saffron and tart cherry, the things that have either been shown or are, gradually they're amassing research data to other people, studies out there to support that it can facilitate either transition to sleep or sleep. But magnesium 3 and 8 and magnesium bisglycinate, to me, are interchangeable with respect to sleep. But magnesium 3 and 8, I'm aware there are some studies that there may be some cognitive benefits. So magnesium obviously could be split into a number of things, but maybe we just start there with 3 and 8 bisglycinate. I have a feeling that you're aware of some additional differences between them, and I'd like to know what you prefer for sleep or for cognitive benefits, and then maybe we get into the other magnesiums.
Yeah, I think so. If we're comparing magnesium bisglycinate or magnesium glycinate, depending on how many molecules of glycine are attached to the magnesium, compared to magnesium L-threonate, the main difference here, and this is based on very limited amount of data, a lot of it animal data with respect to the magnesium threonate, is that form of magnesium is supposed to get into and cross the blood-brain barrier more readily and get into the brain better. And in the brain, it's, helping facilitate neurotransmission, et cetera, right? Helping improve cognitive function. And so whereas magnesium glycinate or bisglycinate, you're having the magnesium attached to the glycine. Glycine also is great to take for sleep. So I like to take magnesium bisglycinate or glycinate for sleep. And so that I would say if you're interested in more the cognition aspect.
Well, the studies, I think you're referring to the Goursong-Lewis data, show in mice, some cognitive enhancement or at least some offsetting of cognitive decline. Those are different but related, obviously. In anticipation of today's discussion, I was able to find one study, seems okay, it's not a huge sample size, showing a positive reports on sleep quality after magnesium L-threonate. So the studies are starting to show up. But there aren't a lot of studies on magnesium for specific outcomes in humans. And I think it's because it hits 3,000 plus pathways.
There's a lot of pathways. Yeah, it's a cofactor for many enzymes.
So if you're taking bisglycinate before sleep, are you taking it a half hour or 60 minutes before sleep?
I'm usually taking it, I would say, a couple hours before bed. Sometimes I add a little bit more magnesium in the mix, depends on the day and if I exercise more, because you do sweat out magnesium. And so if you're pretty athletic, your requirements can go up by even as much as 20%. But yeah, the magnesium L-threonate, it's interesting. I very recently got interested in experimenting with it. There's a little bit of human evidence as well that it improves cognition. Not strong, but again, it's that, we just don't have a lot of people researching it. And we have the animal data. The animal data is a little stronger. Don't have a lot of human data, but it seems to signal it might be important. It might help with cognition, right? And so I kind of got interested in experimenting with the magnesium L-threonate, which I haven't usually. It's a new thing for me. I've been doing magnesium glycinate for a while.
I think this study actually looked at the Magtine version.
Yes.
I have no financial relationship to Magtine. I want to be very clear. I just mentioned that because that's a common one out there. And as far as I know, I'll double check, but they weren't paid by Magtine. But
I think the Magtine did fund the study.
Oh, they did?
So yeah.
Okay. All right.
But,
we'll put a link to it.
Doesn't discredit it unless there's some, bad things going on, which I like to think not. I mean,
it's supposed to be done independently. I mean, when they pay for a group to do, I mean, by law, they're supposed to blind the data and not bias the outcomes.
Right. I mean,
one hopes that's what they do.
Yeah.
Yeah.
And I think for the most part, you're probably okay. But it is something to consider if there's a potential COI, right? But yeah, so I don't know. So that was the first part of your question, was the difference between the glycinate and the threonate. And then the concern that I might have, which might be something you're not thinking about, is, okay, well, I need to fulfill my magnesium requirements, right? And so our daily magnesium requirements, again, based on our gender and our physical activity, it's a range. It's a sliding scale. So, women, 300, 350 milligrams a day, men, 350, 400 milligrams a day, really depending on how physically active you are. And this is just, your daily requirements to have enough magnesium to run, repairing DNA damage, to run. You need magnesium to make energy, to utilize energy. You need it for neurotransmission. There's so many different, important functions in our body that require magnesium to work to convert vitamin D3 into the active steroid hormone. And this to me is to some degree vindicating, but also I'm super annoyed by it because, we have all these different studies out there on vitamin D supplementation, and is it important? And I mean, there's so many negative data out there. Well, it doesn't do what we thought. It's not doing anything. But half the U.S. population doesn't get enough magnesium. And so those enzymes that are important for converting the D3 that you're taking into the active steroid hormone are not working properly. So anyways, I'm not going to go on that tangent, but I'm just saying magnesium is doing a lot of things. So if you are taking the magnesium threonate, and let's say it's going into the blood, the brain more readily, then the concern would be, well, not enough of it is around for, DNA repair and other organs and stuff. And so you might want to get another source of magnesium. It's all theoretical, right? And like, there's no data on that. So just mostly because no one's looking at it. No one's investigating
There's
it.
not a lot of incentive. It's funny when people will always say, well, there's no incentive because the drug companies can't make a lot of money on it. And sometimes that's true, but I have to chuckle because as scientists, I will tell you folks, and like, I wish I could just like paint this across the sky, but then I get accused of being like a chemtrail person or something. The reason there's no studies on BPC 157, the reason there's no like RCTs on a randomized control on different forms of magnesium and large sample sizes, because we barely have enough money to fund the current research. Like I'm not trying to make this political, like we just had a 1% increase in the NIH budget, but like there isn't an infinite amount of money to run studies. And so scientists are, if they already work on magnesium or it becomes interesting to them because it came up in a screen of pathways, there are not a lot of scientists sitting around going, oh, like maybe I should compare magnesium malate, bisglycinate, 3 and 8 in sleep in 2,000 subjects, male, female, like pregnant and perimenopause. Like, no, there's no money to do it. Like, so that's where I get back to, is it safe? Do you want to be in the experimental or the control group? Can you afford to be in the experimental or the control group?
Yeah.
I feel like that's like all we've got. And I'm chuckling out of, it's a sort of like a laughter of pain because I get where people are coming from, but the drug companies are not like avoiding studying magnesium because there's no money to make. It's because, I don't know, what would that even look like? What endpoint? What disease? What like, yeah. Anyway,
Yeah.
Forgive me for editorializing.
You're not going to cure, cardiovascular disease or cancer by taking a magnesium supplement. I mean, these nutraceuticals, these vitamins and minerals, they're about prevention, really, and giving your body the right nutrients that it needs to do and function properly. Whether that is getting enough sleep. When you're stressed, when your cortisol goes up, chronically, you're depleting magnesium. It's very like magnesium is being used to deal with that stress, right? So there's a reason that we need things like magnesium and vitamin D. It gets converted into steroid hormone, changing 5% of our genome. So it's different. It's not like a pharmaceutical where you don't need this, to function optimally, but it's the whole like, okay, I'm sick and now I need this, or I'm overweight, right? We got the GLP-1s, right? I'm fat, I'm obese. And I need to, help fix that. And so that's kind of a different paradigm than
specific endpoint type stuff.
Yeah, exactly.
Yeah, I think that's super important for people to hear that. Oh, by the way, I should just say, for your sake, and for the listeners, I divide supplements into basically 4 categories, like food replacement, like whey protein or a protein bar, or
Right.
obvious sort of general support, specific effects, and then experimental maybe.
Yeah.
And so I think what we're talking about here with magnesium is kind of combination, maybe helps with sleep. Some specific effects that you're aware of, like required, and you're trying to top off. You're trying to make sure that you're covering a deficiency.
Yes.
Okay.
Yes.
Got it.
Trying to make sure you're getting enough of the magnesium. Exactly.
Are there any other things that you take that are just trying to make sure that you're not deficient anywhere, or for specific reasons? We've talked about a few along the way here: glutamine, vitamin D, omega-3s, creatine.
I take a multivitamin, and that is to cover my bases because there's a lot of things in a multivitamin. You have to find obviously a good quality one, but and anyone that tells you that multivitamins are useless, they're wrong. I'm going to tell you that they're wrong, because I think now we have pretty strong data, 3 very large randomized controlled trials, part of the Cosmos trials. Have you heard of these studies? And it's really, I think, pretty clear that in these studies, older adults, so we're talking 65 years and older, that are taking a multivitamin supplement for, was it a year? I think it was. It could be 2, but I think it was a year. And it was, by the way, Centrum Silver. It was like your standard, anyone could afford to get it at Walmart type of vitamin. And after a year of taking this multivitamin, it globally reduced brain aging by about 2.1 years. 3 trials globally reduced brain aging by 2.1 years. Battery of tests that are done, right? I mean, it's,
Sure.
I'm just talking about general here. And it also reduced episodic brain aging by 4.9 years.
Wow.
So that would be, as people probably are already familiar with that listen to this podcast, episodic memory, that's the part of memory that's involved in like remembering events and people and like experiences. Am I right? I mean, part of like not as much
sequence of things.
Sequence of things, yeah. And so, that's a big effect for just a daily multivitamin, And so for that reason, I've been taking it before these studies came out, but my parents, anyone that's older adult should be taking a multivitamin. So that's another one that I take. And I take it to cover my bases as well. I'm obviously not an older adult, and who knows, it might not have the same effect on me, but it's one of those that it's not harmful. If I'm, it's a little bit of an expensive urine, fine, but it is covering some of my bases in terms of some of the micronutrients in it, right? The other ones that I take in besides the one that you mentioned, which is vitamin D, omega-3, I do creatine, magnesium. I do magnesium glycinate. I should look into the bisglycinate because I definitely would like another molecule of glycine I like for my sleep. But I also sometimes take another form of magnesium, which it's like a mixture of magnesium malate and taurate, I think, and glycinate is also in that. But sometimes I take that for sleep. And then I take ubiquinol for mitochondrial health.
You like the data on that, obviously, if you're taking it.
There's stronger data, I think, on ubiquinone, which is the oxidized form. It's more stable. There's just, when I say stronger, I mean more data.
Do you take coenzyme Q10?
So CoQ10 CoQ10 is ubiquinol.
Okay.
Yeah, and so I'm taking the reduced form of it, which is ubiquinol. The more stable form would be ubiquinone.
Are those trademark names? Because I take coenzyme Q10.
You're taking.
I'm guessing if I took a closer look at the bottle, I'd see the ubiquinone.
It's ubiquinone.
Okay.
Yeah.
Ubiquinone.
The ubiquinol is a little bit more bioavailable, but yeah. So I'm pretty convinced that helps with mitochondrial function. It's not like you could always have more data, right? So we'll just leave it at that. The other one I take is now I'm taking urolithin A in the form of, I'm taking Mitopure, by the way. I have nothing to do with these companies. But I've just been over the years increasingly interested. So urolithin A is something that is formed from a type of polyphenol that's found in some fruits, like pomegranate being the main one, I think. And raspberries may also have some, I think walnuts also, but it's elagitanin is the polyphenol, and these elagitannins get metabolized by the gut microbiome, and the metabolites that are formed, one of them is called urolithin A. And so urolithin A is a compound that seems to stimulate the process of mitophagy, which is a very specific form of autophagy that's only for mitochondria. And that's been shown there have been randomized controlled trials showing this in humans. It does stimulate mitophagy, blood cells as well as muscle biopsy, but that's an important cleanup process for how our mitochondria repair themselves. There's no repair enzymes, right? Like they're, part of that repair process is mitophagy, where they're selectively can get rid of parts of mitochondria that are damaged. So it's really a rejuvenation. And some of the clinical data, I would say, is emerging. More needs to be done, but it seems to, in some cases, improve endurance performance, which makes sense because they rely heavily on mitochondria, but even also help with the immune system and this whole inflammaging. So it helps keep immune cells. It seems like it's helping keeping immune cells, quote unquote, younger. So again, emerging data, but I'm in that, I'm the experiment group. It seems to be safe, and I'm not taking too high of a dose. So that's another one that I'm supplementing with. The other one that I'm taking also is a form of, I would say, I'm going to call it sulforaphane, but it's not sulforaphane. It's the precursor to sulforaphane, glucoraphanin, because that's more stable. And so I take something called Avmacol, which the reason I take that one is because there's, it's 13 now. A new study just came out, 13 studies using that form. And sulforaphane is also one of those plant phytochemicals. It's found in cruciferous vegetables. As you know, we've talked about this before, so I'll try to make it brief. But so glucoraphanin is in these cruciferous vegetables like broccoli. Broccoli sprouts are a really, really great source of it. And when the plant is crushed, like when you eat broccoli or chew it, whatever, an enzyme is activated that converts glucoraphanin into sulforaphane. The reason I take it is because I've been now convinced by, I would say, the limited number of human studies, clinical studies, but also the totality of evidence looking at cruciferous vegetables in general, and then also animal data, that it's really important. It's probably the best naturally occurring dietary activator of a stress response pathway that is important for detoxification. And that pathway is the NRF2 pathway. I'm sure you've heard of that pathway. Sulforaphane is a very, very powerful activator of that pathway. And what I mean by pathway is that gene is turning on and turning off many, many other genes. What we know about it is that it's very important for activating the detoxification genes that are involved in detoxifying things that are harmful to us. And so the classic studies that have been done, most of them in China, where air pollution is very high, is that if you take, this broccoli sprout sulforaphane extract, you can start to excrete compounds that are found in air pollution, like benzene, that are carcinogenic, right? And you can start to excrete it after 24 hours by like 60%.
Great.
So
what about plastics?
So that's my
Right,
thing.
yeah.
That's why I'm taking it in my whole family, because the same enzymes that are activated by the sulforaphane that detoxify benzene. So basically, you're detoxifying it. What I mean is you're basically making it water soluble, so you can excrete it through urine. Mm-hmm. Okay, the same ones. That's exactly what those enzymes do to BPA. They make it water soluble and help you excrete it through urine. There's no human data showing this yet. I want someone to do the study. But we do have animal evidence where animals are given a high dose of BPA and sulforaphane, and it protects against the toxicity. Mm-hmm. I basically think that someone's going to show it, and it's going to be clear because the enzymes that are involved are activated by this, by sulforaphane, and that's been shown with benzene and acrolein excretion, right? So why wouldn't it be BPA?
Yeah,
Never
the
know.
mechanistic logic is there.
Yeah, exactly. Mm-hmm. So that's another reason why also it increases, it's been shown in human studies to very powerfully increase glutathione in both the plasma and the brain. And that's also through the NRF2 pathway. It activates the powerful antioxidant pathway. It also deactivates phase 1 biotransformation enzymes. Those are involved in turning a procarcinogen into a carcinogen. So those are things like you're eating, you're grilling your meat at a high temperature and you're getting heterocyclic amines, right? I mean, these things can be harmful, but our body can deal with it.
Yeah, we had a cancer doc on here recently, and I was scared to ask him the question because I didn't want the answer, but I did want the answer of the char on meat.
Yeah,
and he's like, it's pretty serious carcinogen. That's real. I mean, the occasional thing isn't going to be a problem. You'll be relieved to know, and this is not a promotional, that the can that you're drinking out of, these are intentionally BPA, BPS, and PFAS free. We test them. I'd be happy to send you the results.
I already know. I already knew about that.
Because I know that you and I are both. I am wary of the BPAs and the rest. I think it's wild that 10 years ago, people like Charles Poliquin were saying, don't handle receipts. And, and everyone was like, this is really kooky. Or actually back then, no one even heard what he was saying. It was such a niche thing. Then people were very, I think, disparaging of people saying, be wary of receipts. Now, I think the microplastics and the BPA, BPS, PFAS concern is really taking hold more broadly. Mm-hmm. And I think that, the tables have turned. Yeah.
And really, obviously, you can't eliminate them completely. It's impossible. They're everywhere.
Yeah.
They're everywhere. I mean, we're
clothing, I heard, is the main.
It's the main source of microplastics in the ocean. Right, because we're washing our clothes, and this cute shirt that I'm wearing. I mean, it's got microplastics in it for sure, and so every time you're washing your clothes, all the microplastics are coming out and getting into the ocean. And also then when you put your clothes in the dryer, and if your dryer is ventilating anywhere in your house, you're breathing those in, the microplastics.
They sell these traps. When I did the episode of microplastics, I found out that they're online. I think it costs, it's not cheap, but it's like, considering they last a while, I think they're somewhere with refill somewhere in the neighborhood of, I want to say something like $70, but it supposedly traps the micro.
In the washing machine.
In the washing machine. Yeah. And in Europe, I think this is actually built in or is required in a number of countries. Like they're way ahead of us. They're way ahead of us on a number of things. I mean, on a few things they're far behind, I must say, with respect to health, but on many things they are way ahead of us.
Yeah, well, clearly with the people in Switzerland being 88% of them being physically active, they're way ahead of us on that.
I'm excited to share with you that Matina, the yerba mate drink that I helped create, is now available at Sprouts Market nationwide. Longtime listeners of the Huberman Lab podcast know that yerba mate is my preferred caffeine source. It provides a smooth energy lift without giving you the jitters, and it has many other benefits, such as helping regulate blood sugar, improving digestion, mild appetite suppression, and more. Matina is my absolute favorite of all the yerba mate brands out there, and believe me, I've tried them all. The flavors are fantastic. I drink at least 3 cans of Matina every single day. You'll often see them on the table during our podcast recordings. I absolutely love the product, and I'm proud to now have it sold at Sprouts Market. Also, there's a great new offer. They are giving away a free can of Matina to anyone who buys it at Sprouts and sends in a photo of their receipt. To learn more about how you can get a free can of Matina, go to drinkmatina.com/offer. Again, that's drinkmatina.com/offer to get a can of Matina for free at your local Sprouts Market.
What is your threshold for you? And what do you think is kind of reasonable levels of what's actionable for you? Like, how do you set that? I think it will help people kind of understand how you're approaching stuff.
What's actionable in terms of improving, what I'm interested in improving my health, like
Yeah,
versus,
like, I mean, without picking any specific example, like when you look at the literature and you see, let's take BPC 157. It's kind of a fun one because everyone's excited about this now, except the physicians who don't like working with peptides besides GLPs or other FDA-approved peptides. They're like freaking out online.
Okay.
From them all the time. Compounding pharmacies just got the green light that they're going to be able to do basically whatever except sell retatrutide, which is under patent. So there are many, many animal studies on BPC 157 showing accelerated cartilage growth, nerve growth after injury, and on and on and on and on, and angiogenesis. So there's some potential cancer risks there, right? But basically zero human data. There's one study, weak study, self-report. There's actually a clinical trial where I'm not making this up, folks, is BPC enemas, very high doses for some sort of bowel disease or bowel inflammation. And the study was like, I don't think the study was completed or something like that. Don't ask me why. No, I'm not making this up. But that's pretty much the only human data that I'm aware of. But tons of people injecting and swallowing BPC and saying, yeah, it helped me recover, heal more quickly. How do you think about something like that current condition?
First of all, if you're not doing it, you're not going to be doing this every day forever, right? Like this is a short defined period of time where you're going to do your injections. Yeah. Oh, really? Yeah. Okay. Well,
I know. I mean, I don't know what people do. Unfortunately, I think some people like to take it every day, but let's assume 2 months maximum to work around an injury or through an injury.
Yeah. I like for people that I know that have experimented with it, it's been like 3 months and a period of time, and they did have improvements, and they could have been through placebo, which I will, say is possible. But for me, it really comes down to like, is it safe? Is it safe? Okay. If it's safe, you obviously have to get the good source, because if it's all these pharmacies now, I mean, that's a problem, because we do know that that's a big area of, I would say, concern with any sort of nutraceutical, sort of thing. And I would put this into that category is that, people are putting things in the products that are not necessarily what's supposed to be in there. And they're not really paying attention to quality because it's not regulated. Right. So if you can get a good source of it and you trust the source of it, and you have maybe someone who is qualified to prescribe it to you, because there are, naturopaths and stuff like that, functional medicine practitioners, there are people that are prescribing them.
And some MDs, some board certified,
some MDs
did their residency, did all the things. I know because I'm friends with some of them. Right. And a lot of doctors are happy to prescribe peptides sort of off-label, like sermorelin for purposes other than what it was FDA approved for. I mean, I'm not taking it, as I mentioned earlier, but
you've tried it.
It very quickly spiked my PSA and nuked my REM sleep and increased my deep sleep. So I was like, I'm not interested in those effects. And I do worry about tickling the growth hormone pathway too much or too long because of, hopefully I don't have any tumors sitting around, but if I do, I don't want to vascularize them or grow them.
Right. Yeah. So for me, I mean, I'm always more on the cautious side, to be honest. And so for me, the safety thing has to be checked first. And then at that point, if I can check the safety thing, then it's like you said, I mean, I'll try it. Like, I mean, I'm doing like some of these supplements that like Mito Pure for one, like the urolithin A. I mean, there's not like tons and tons of data on it, but it seems to be safe. and, I'm experimenting with it. I'm also experimenting with a lot of other things, so it's hard to know what's working.
Sure.
Nicotinamide riboside is another one I take. Back onto what I take.
Is that for a longevity effect? I mean, I take sublingual NMN. No relationship to any company that sells NMN. At least the one I take is from. They hate it when I do this, but from Renew by Science, it's the cheapest version. That's not why I take it. I just like the powder put under my tongue. I like the energy effect. Yeah. I will say this, and I've done the control experiment on myself, and I have family members who've done it too. It makes my hair grow crazy fast, and my nails grow crazy fast. I know this because if I stop, that halts. Those aren't really effects I'm looking for, and it worries me a little bit because what else is it making grow crazy fast? Again, I don't think I have a tumor, but what else is it? If I have like a polyp or something, is it making that grow crazy fast? I don't know.
I asked that question to Dr. Charles Brenner when I had him on the podcast because there was a study on NMN in mice that the mice had tumors, and then they gave them, I think they injected them with NMN, or maybe it was oral gavage. I don't remember which way it was, but it accelerated the growth of those rare type of pancreatic cancer cells. And so I was, obviously energy, yes, cancer cells love energy too, right?
Brenner doesn't like NMN. And I will take NR sometimes. I do take True Nitrogen.
Right. Well, it doesn't, I mean, either way. So the same endpoint here, we're increasing NAD, right? So the question is then, okay, well, should I be worried about cancer? And he pointed me to some study out of Australia where I think it might have been nicotinamide that basically prevented some kind of, it wasn't melanoma, but it was another type of skin cancer. And so I was like, okay, well, that seems sort of good point here. I am experimenting with it. Why? First of all, I became interested in it because the effects on mitochondrial health. There was effects on fertility, energy recovery when I started. It just, and then again, you can find a couple of studies where maybe, you're not as insulin sensitive, and who knows? Like it's there's not enough data there. So I would say I'm cautiously experimenting with it. But so far I love it. And you never know what's placebo here.
So I do take, and they don't pay me, I buy it. I do take True Nitrogen. NR.
That's what I take, yeah.
NR. And on the data sheet, they include some human studies. I have a family member, I'll just say, my sister takes it. She loves it.
Yeah.
She's convinced. Now, that could be placebo, but she is so convinced. She texts me about it. I feel so much better. I have so much energy. I have no idea. She has no idea if it's placebo, but Brenner's a very good scientist. I will say he's what we call in our business, you and me, a serious scientist. Yeah. I just don't think any of that's going to make me have a direct effect on living longer.
I don't know that it is. I don't know that it's not one of my, if I had to shrink down to my core supplements, it wouldn't be in there. And, there's many other things that are important, I think, before.
So if you were budget limited, it wouldn't get above threshold. Like if someone out there had just $100 or $200 to spend on supplements, which is a lot for a lot of people.
I don't know that it's going to help you live longer either. Now, it might help with your exercise recovery a bit, right? It might help improve mitochondrial function. I mean, maybe it's going to help with repleting some of the NAD stores. I mean, if you can improve mitochondrial health, and you're improving things on a small scale, right? So mitochondrial health is at the core of everything. So that's something to consider. But yeah, I'm not convinced it's the end all be either, but I do take it. And it is something I'm experimenting with. I think it seems to be safe. And there's a lot of emerging data that caught my interest. But omega-3 is the top, right? There's nothing NAD, the nicotinamide riboside or NMN, if you can find a good source of it, that's not comparable in my books.
Have you experimented with L-Carnitine because of the mitochondrial effects? Because I was able to find some good studies on sperm and egg quality, on which are thought to be downstream of mitochondrial health.
Right, it's downstream.
That's the idea.
If you can improve mitochondrial health, fertility, which is why NR is now involved with fertility. It seems to be improving fertility. It's right. If you can improve mitochondrial health, then you're going to improve fertility, sperm health, right, egg health, right? L-Carnitine, a lot of those studies came out of my mentor's lab were same. So he looked at the combination of L-Carnitine and alpha-lipoic acid improving mitochondrial health. And came up with the supplement that it's called Juvenon now, but it's L-Carnitine with alpha-lipoic acid.
It's a pill.
It's a supplement,
okay.
Yeah. And so, yes, I have experimented with that. And in fact, my husband takes it. But I mean, I just can't take so many supplements.
Right. Yeah.
So
I was just curious.
We have our, but it is, you can find evidence that it improves mitochondrial health. So, it's just a matter of, again, like what are you looking for? I feel like I'm doing a lot of high intensity interval training too, and I'm taking the Urolithin A. That's a lot, I'm doing a lot of stuff to optimize mitochondrial health. I mean, at some point you have to you can't do everything there is.
Sure. No,
but,
of course not.
Yeah,
and then it's budget limited
but
too.
Maybe, maybe I should add the L-Carnitine in.
I'm not saying
possible,
that.
Right?
I've started experimenting with it, but I take it in an injectable form.
Really?
It's going to shock some people. You can get away with taking much lower milligram count. Otherwise, you have to take a lot of it because a lot of it just isn't absorbed if you take it orally. And then I was told that if you take it orally, you also have to do something to offset the increase in TMAO. And that worried me. So I figured needles don't scare me. I'll just inject it.
Interesting. Yeah. The TMAO thing. I mean, it depends on your gut bacteria, whether or not you're metabolizing the L-carnitine into TMAO. There's actually a lot of complexity involved in that whole thing, but you can get your TMAO measured. So if you were supplementing with it, I mean, the same goes for choline, if you're worried, like choline can be converted into TMAO.
I'll take Alpha-GPC before a workout sometimes, or if I need to, if I ever need to focus late in the day, I don't want caffeine because it impedes my sleep, but I'll take Alpha-GPC because this is kind of a cool effect. Alpha-GPC actually will improve your REM sleep. It's not a huge effect, but you'll notice you'll get more REM sleep. So it's one of the few things I found that can increase energy late in the day, do a workout or work if I have to work later into the day, still sleep just fine and actually sleep better.
What does work later into the day mean for you, like working until like 8, 9 o'clock?
Yeah, later? Well, I do that often, but I don't like to work out after 2 p.m. because I like caffeine before I work out.
Yeah.
But I'll do some cardio in the afternoon or something. But if I really have to push, or if I've traveled and I really need exercise and I want to get a 6 p.m. workout, but I also want to fall asleep at 10:30, I'll take some Alpha-GPC.
I used to take that, I don't know, it's been maybe like 10 years, but it's interesting. I might try experimenting with that again. I'm always looking for things that I find a little bit safer. Like I don't do the nicotine, as you know. Like
it is shocking how many young people are taking nicotine.
Oh,
now.
I know.
Yeah,
I've never tried it.
First of all, it's highly addictive. Forget the blood pressure and the vasoconstrictor.
Yeah,
that's all bad.
Right.
I think the big issue is that if I take it, I start getting this spasming in my throat when I don't take it. And that's because I have a friend who works on these pathways, and it's because of the activation of the muscarinic receptors. So on smooth muscle, you start getting a tick and kind of a clearing of your throat, and then you take more nicotine, you feel fine. So I didn't want to become dependent on it.
Yeah.
And I don't like it. I think it's a bad habit that a lot of people are going to be seeking to quit later.
A lot of young people.
Older people might benefit from it because of the cognitive enhancement, but that's a whole other story.
Well, maybe the Alpha-GPC and the creatine and magnesium L3.
Yeah. Alpha-GPC is very helpful for if you need to really lock in for a few hours and do something physically.
What dose?
I take 600 milligrams. You can take up to 900, but I do just fine on 600. So I think I'll just take it in pure form and, in capsule.
Yeah.
Any of them out there that come from a reputable brand is going to work.
What about like before a podcast or something like that? Does it have any effect or why?
Oh yeah.
It does?
It'll put you into, if you feel like you want to be heightened focus, but I rely on water, caffeine, electrolytes, and good sleep. There's this wild study. I don't want to take us too far off track here. But there's a study out of WashU recently, really, really talented researcher. I want to bring him on this podcast, does brain imaging, and he compared essentially the effects of drugs for ADHD versus a good night's sleep, and basically found that there's no focus enhancement of Adderall, Vyvanse, Ritalin type drugs. They mainly looked at Ritalin. All it's doing is increasing alertness to the level that you would get after a good night's sleep. It may be that these drugs just increase alertness, which allows you to dial in focus. But if you're sleeping well and enough, you make up the gap, and people with ADHD might just be having some serious sleep defects.
Right.
So, it speaks to this thing, like, I don't know that there's a single drug that can actually increase cognition and focus. Most of them probably just get you in the plane of alertness that allows you to dial in your focus. Some people will be like, that's BS, they take modafinil, but this is just another form of increasing alertness.
Well, reducing anxiety, I think things that are anxiolytic help with that as well. And I think I was talking about, I don't know if I was telling you or someone else before the podcast, one of the reasons why I also like that metabolic switch with the ketosis and the beta-hydroxybutyrate, and sometimes I'll take exogenous ketones too. Although if you take them in a fasted state, it kind of shuts down the lipolysis. But anyways, is because it increases GABA. The beta-hydroxybutyrate increases GABA. And for me, it's beneficial because I am the phenotype where I I can have other things going on in my mind that it's not anxiety, but it's more of that anxious phenotype, if that makes sense. And so the increase in GABA really does help me with focus because it's quieting down, I think.
I actually think that a lot of people who are very intellectually engaged, which clearly you are over many, many years, and very physically active and healthy, there's a lot of capacity there. And unless there's something to really absorb all that capacity, you can get multiple tracks going. And we sometimes think of that as anxiety or even ADHD. Some people will say it's ADHD. I don't necessarily think it's that, but it's an uncomfortable state to be in. And it's so pleasurable to be like where all one's resources, physical or cognitive or both, are harnessed. It's a very pleasant state. Earlier, you were saying the GABA increase from the ketosis. I think more and more we're just realizing that people have differing levels of excitatory to inhibitory balance in the brain. And so some people like things that bring GABA up. Some people like things that bring glutamate up, broadly speaking. And finding that sweet spot is where you go, oh, like I'm alert but calm.
Right.
And that's what we want.
That's what it does for me. Alert,
awesome,
but calm.
Great.
And for me, I'm like, and I noticed that there was a few years ago, I really experimented with a ketogenic diet. I just can't do that type of diet, but I did experiment with it. And that was one of the main things that I noticed is like, I'm alert but calm. And it's like, I liked it.
Well, then don't take nicotine, because the reason people like nicotine is it's a stimulant that calms you down. So I do think that one of the reasons it's so habit forming is because I know of nothing else that puts you in that plane of focus of alert but calm, that is reasonably low cost, that is legal. I've never done amphetamine or cocaine, so I wouldn't want to, and clearly that's a path to destruction. So the reason so many young people are taking it is because it gets them right in that plane of alert but calm, but it has all these negative effects that go with it.
Yeah, and that's why I have stayed away from it, because I know I probably love it.
I've asked some young folks who ask me about nicotine, how many milligrams are you taking? They'll say 9 milligrams. I'll say, how many times per day? And they'll say 8 times per day. I'm like, oh my God, like that's crazy.
But they didn't start there.
You just quickly get there.
You adapt.
Yeah, so I don't want to sound like that curmudgeon that's like, don't drink and don't take nicotine and this kind of thing, but it's a slippery slope.
Right. Yeah.
Really,
I mean, there's other things that you can do that maybe it's not going to be as potent, but
Alpha-GPC.
Alpha-GPC. And for me, I like my metabolic switch and my ketones.
Nice.
And
well, I'd be curious to hear how you feel on the Alpha-GPC.
I remember liking it. I don't know why. I think I stopped taking it because I got pregnant. Is probably what it was. And then
That's a good reason.
It's one of those things where you just forget. You go back to the basics and then like the
different experiment.
Yeah.
Before I came on here, I did put out a call for some questions to the world.
Okay.
Rapid fire Q&A from the land of X and Instagram. These are the students of the class, of your class. And this way I think about it. Actually, I wanted to ask about this. So I'm so grateful that this person asked about nattokinase for improving blood lipid profiles. Is it something you're interested in or have experimented with?
It's not something that I've experimented with, and I've been more interested in the nattokinase. I know I really would have to say I don't have enough data to really have an opinion on it.
Okay. Well, I don't have enough data to have an opinion on it, but I take it anyway. A lot of questions about things we already talked about. So cold plunge, et cetera, but an exceptional number of questions about microplastics. And I know we touched into it, but on a scale of 1 to 10, 10 being like you're really concerned, how concerned are you about microplastics for mental and physical health, longevity, just broadly speaking?
I would say I am less concerned about microplastics than I am about not getting the right nutrients and micronutrients from our foods, because our body can detoxify at least some of the chemicals associated with them. The microplastics themselves, I mean, I guess we don't really know what they're going to do long term, but I'm concerned enough to try to limit my exposure to them as much as possible.
So you don't drink out of plastic water bottles?
I mean, I try not to as much as possible. I mean, I definitely have to at some points, but I try not to, yes. And when I do, I just realize it's the habit, and you kind of have to let go. I mean, I know some people that like don't drink, and like they're going to get their water from their fruits while they're traveling. Pretty extreme. Yeah. But I think mental health is important. So I mean, it's like, is the stress of avoiding the microplastics worse than the actual little bit of microplastics you're being exposed to? It might be.
TSA is going to hate me, but I lost a bet 2 days ago to a member of our podcast team. He bet me, we bet, that I said one couldn't bring a Mountain Valley spring water bottle through security at the airport. And he said that you absolutely can. And I said, there's no way. So I made him a bet and I lost. He brought it through.
Full of water?
Full of water. You tell them it's for medical reasons. You don't have to state what they are. They open the cap. They take a sample out. They test it. So there's a time constraint and it's going to create more jobs for TSA. Sorry, that was sort of a joke, sort of not a joke. TSA has been, in tricky circumstances lately. And he showed up at the gate with it and was like, here's your water. You absolutely can bring water through in glass vessels or whatever vessel, but they're going to test it. And it helps if it's a commercial vessel. It's not like your own glass water bottle.
Can I pause for a minute? Because you mentioned a specific brand, which I also, when I
don't make money from them.
Right, same. I drink, when I'm traveling, that's the brand that I go to. And there was a study that came out showing that there's actually a larger volume of microplastics within this study from glass bottles versus plastic bottles, which was a very shocking finding. So there's more microplastic number coming from the glass bottles. It turns out, this was a study out of France. There was a study out of France and also in the U.S. It's the paint on the lids. You mentioned the lid. And so it's the paint on the lid that's getting contaminated in the bottling of the whole bottling of this water that is getting into the water. But I do want to mention that the size was shown to be larger from the glass bottles versus the plastic. So the microplastic size was larger. And as you probably know, larger microplastics are not well absorbed through the gut epithelial cells. So when you're, taking them in the gut, they're coming out, they're being excreted through your feces and less likely to be taken up into your gut and then get into your body. And that's actually well known. And so I'm actually more concerned about the size of microplastics. And it wasn't like the huge orders of magnitude difference between the water from glass versus the plastic. It's so counterintuitive. You think, wait, what? Why is it? So it's the paint that's on the lids. But anyways, I just want to mention that I still drink when I'm traveling. I still go for the glass, not the plastic, because of the size of the microplastics and knowing, because the size was much bigger, that it's very, I would say, more data is going to come out on this, but I would be surprised if you're absorbing more of the larger particles because it's known that you absorb the smaller ones.
Thank you for that. And if you want, you can now take your glass bottle through security full. Seed oils, the dreaded seed oil debate. Where do you land on this?
I try to avoid them, mostly because, one, if you're avoiding seed oils, you're going to avoid a lot of the processed packaged foods that they come in, which I know are terrible for you. Two, because I think that cooking them or heating them, is more of my concern because they are, polyunsaturated fatty acids, which are very prone to oxidation. And when you're heating something that's prone to oxidation, you're accelerating that whole process. I don't want to consume oxidized lipids. I've looked into that literature, and the last time I looked into it was, I think, 2024. At that time, I was pretty convinced that if you are heating and reheating, oils like they do in fast food, for sure, you're increasing inflammatory markers. That's been shown. And I think also when you're really having a higher level of, omega-6s and stuff around, I'm not as concerned because I'm getting a lot of omega-3, but it does also increase your vitamin E requirements as well because of the oxidation of these polyunsaturated fatty acids. So do I think it's like the worst ever? You can find all this data out there showing that, if you replace, saturated fat with some of these seed oils, there's improvements in lipid profiles. But at the end of the day, the question is really, what if you had olive oil instead or avocado oil instead? Would it be even better? I think possibly. So if you're really trying to go for the optimal, I avoid them as much as I can for that reason. But I think there's a little bit more hype when it comes to the seed oil. But if that makes sense, I'm kind of, that's my take.
Makes sense to me. For what it's worth, I stick to olive oil and
Same.
Small amounts of butter. And that's because I also think seed oils taste terrible. How come no one talks about that? But anyway, and olive oil and butter are delicious.
It's been so long since I've actually had the seed oil, but yeah.
And no one can convince me that they don't taste bad to me. So then the debate just kind of falls away. How often are you doing the sauna nowadays, and what does the top contour of that protocol look like?
So I've taken a little pause on the sauna right now, but typically I was doing it like I would say 5 nights a week. And I say nights because I was usually doing them in the night. And it was a mixture between either getting in the sauna or hot tub. So I like getting in the hot tub, head out under the stars there with my husband. It's
Nice.
like our time.
Awesome.
So yeah, usually it's like 20 minutes, and temperature wise, I don't go that hot. I'm like 180.
5 nights a week is great. Gosh, I need to get back on a 5-night-a-week sauna or hot tub protocol.
I do like the hot tub, especially. I don't know. There's something about being outside, and I think now there's evidence that the benefits are really like the same. It's the deliberate heat exposure, right? You're getting that through the hot tub or through the sauna.
Creatine for kids, like young kids, like younger than 16. Any data and/or ideas about this, good or bad?
Yeah, so there is data in the literature showing that if you give younger children that are doing, like, for example, sports like soccer, it does seem to improve their agility, and it seems to be safe. I do give my son 2.5 grams of creatine, so a day.
Cool.
So that's how I feel.
There's no better indication of how of how one feels and what they're willing to deliberately give their kids. I don't know where this stems from, and we can cut it if you want. But someone asked, why did you single-handedly ruin bananas? For this person?
Yes.
Did you ruin bananas?
So I used to put bananas in my smoothies, and there's an enzyme that is produced in bananas that break down polyphenols, particularly ones that are found in blueberries. And the reason I was getting my smoothies was 1 for the greens, but 2 for the blueberries, because the polyphenol has been shown to improve cognition. Love blueberries. So sorry, don't mix the blueberry with the banana smoothie, because it has been shown to decrease the polyphenols, which are important.
Yeah. Yeah. Well, the alcohol industry will come for me someday, and the banana industry will come for you. And I think we're safe for a while. Should we ignore studies that have less than X number of subjects? I think that's a really good question. Like, obviously it depends, but when we're talking about human studies, where's the line for small study versus large, meaningful study for you? Obviously how strongly it's powered, but how do you think about that?
Well, I'll tell you, when I was first looking at the sauna literature, all the studies that I were looking at were like N of 10 or smaller. And it's really the aggregate of those studies, and then looking at like animal data, and then you start to look at observational data and the totality of evidence, and you put together this picture. I don't think you should ignore studies that are small. I think that it's part of the story. I think we're getting a little too caught up in, it's got to be the randomized placebo-controlled trial. It's got to have lots of participants. And I mean, that's great if we have that data, but we don't always have that data. And I don't know that we will always have that data with everything that we're interested in understanding, right? So the way I look at it is, if it's like just one study with an N of 10, okay, interesting. Like with the creatine, right? Like, I mean, these studies have been small sample sizes. Now there's more than one, but, at the end of the day, it's still very, I would say, in this, pilot study phase, right? We have just small studies. So I do not ignore them, but I also don't hedge all my bets on them either. I do know that there were a lot of people that were criticizing me on my sauna. I mean, back in, 2014, published an article on Tim Ferriss's blog, went on Joe Rogan's podcast and talked about, the benefits of sauna. And I had people that were going, your sample sizes are too small. And now we have so much data that has come out since then, really kind of validating everything and showing even more benefits. You kind of have to look at the totality of evidence and what is it, what endpoints are you looking at, and how can you gather, data from different sources, whether it's clinical studies or observational studies or animal studies, and try to come up with the bigger picture. Right. But then also don't be too confident in your statements.
I'm very gratified to know that pretty much every other question you addressed the answer to en route to where we are now in the podcast, truly. And I'll leave them up so you can see them later if you choose. Cold plunges, notwithstanding, vitamin D, exercise in all its contour, specificity, fasting, magnesium, lots of questions about supplements, which we covered, creatine, lots of questions about inflammation, longevity. And so I just have to say, first of all, on behalf of everybody, thank you so much. This was really an incredible tutorial, and so much of it is actionable. And as you are known for. It was incredibly thorough in terms of setting the context within mechanisms of what we know, what we still don't know. And I also personally want to thank you because when you speak, I learn. And when you speak, I also learn things that change my behavior. And that's a whole other level. Since our last conversation, I can think of at least 4 and probably as many as a dozen things that I do on a daily basis as a consequence of that conversation. And just the gut inflammation, health, brain, body axis conversation that we had earlier. I'm going to listen to this again and take notes because there's just so much there. And the metabolic flexibility thing as an input that can come from multiple sources, just on and on. So thank you for doing what you do. Thank you, for being first in and still going and doing things with such rigor and really so much grace. It's just awesome. People love you. I certainly do and appreciate you. And it's just, it's a wonderful thing for me to have a colleague like you, and you really set the standard. So thank you so much for coming here and doing this marathon, and can't wait to do it again.
Thank you so much, Andrew. It's really been great. I learned so much from you as well and appreciate everything.
Thank you.
Thank you for joining me for today's discussion with Dr. Rhonda Patrick. To learn more about her work, please see the links in the show note captions. If you're learning from and or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. In addition, please follow the podcast by clicking the follow button on both Spotify and Apple. And on both Spotify and Apple, you can leave us up to a 5-star review. And you can now leave us comments at both Spotify and Apple. Please also check out the sponsors mentioned at the beginning and throughout today's episode. That's the best way to support this podcast. If you have questions for me or comments about the podcast, or guests or topics that you'd like me to consider for the Huberman Lab podcast, please put those in the comment section on YouTube. I do read all the comments. For those of you that haven't heard, I have a new book coming out. It's my very first book. It's entitled Protocols, an Operating Manual for the Human Body. This is a book that I've been working on for more than 5 years, and that's based on more than 30 years of research and experience. And it covers protocols for everything from sleep to exercise to stress control, protocols related to focus and motivation. And of course, I provide the scientific substantiation for the protocols that are included. The book is now available by pre-sale at protocolsbook.com. There you can find links to various vendors. You can pick the one that you like best. Again, the book is called Protocols, an Operating Manual for the Human Body. And if you're not already following me on social media, I am Huberman Lab on all social media platforms. So that's Instagram, X, Threads, Facebook, and LinkedIn. And on all those platforms, I discuss science and science-related tools, some of which overlaps with the content of the Huberman Lab podcast, but much of which is distinct from the information on the Huberman Lab podcast. Again, it's Huberman Lab on all social media platforms. And if you haven't already subscribed to our Neural Network newsletter, the Neural Network newsletter is a zero-cost monthly newsletter that includes podcast summaries as well as what we call protocols in the form of 1 to 3 page PDFs that cover everything from how to optimize your sleep, how to optimize dopamine, deliberate cold exposure. We have a foundational fitness protocol that covers cardiovascular training and resistance training. All of that is available completely zero cost. You simply go to hubermanlab.com, go to the menu tab in the top right corner, scroll down to newsletter, and enter your email. And I should emphasize that we do not share your email with anybody. Thank you once again for joining me for today's discussion with Dr. Rhonda Patrick. And last, but certainly not least, thank you for your interest in science.